नमस्ते सभी को और स्वागत है आई डोंट नो पॉडकास्ट के थर्ड एपिसोड पर। आज के एपिसोड में हमने काफ़ी ज़्यादा इंटरेस्टिंग कॉन्वर्सेशंस करे अबाउट द एनर्जी स्पेस इन इंडिया, अबाउट द इन्वेस्टर स्पेस इन इंडिया एंड हाउ डू यू इवन बिल्ड अ डीप टेक कंपनी, हाउ डू यू गेट फंडिंग फॉर द सेम। ये इन सब टेंजेंट्स के अराउंड हमने काफ़ी कॉन्वर्सेशन करे हैं विद कार्तिक हजेला, को फाउंडर ऑफ लॉग 9 मटीरियल्स, जो कि पायनियर कर रहे हैं रिस्पॉन्सिबल एनर्जी इन इंडिया। कार्तिक आईआईटी रुड़की से ग्रेजुएट किए थे 2017 में, और वो तभी से उन्होंने ब्रीफली शुरू में 8 महीने आईटीसी में काम किया एंड देन ही मूव्ड इन विद अक्षय हु वाज ऑलरेडी वर्किंग ऑन बिल्डिंग लॉग 9 एंड वहाँ से इन्होंने एक अलग राह पकड़ी है जिसके बारे में हमने काफ़ी डेप्थ में बात करी है अभी। तो रिस्पॉन्सिबल एनर्जी क्या है, आइए जानते हैं। Cool. So we are live. Welcome again, Hajera. क्या हाल है? How are you doing?
I'm good, man. How are you? How are
Good,
you,
good यार.
Aishwarya?
Cool है यार. I think what is very interesting, what has been very interesting. I mean, Log9 अक्षय सर के साथ तुम्हें भी देखा ही है मैंने काम वाम करते हुए, तो इट्स अ वेरी इंटरेस्टिंग फील्ड सो टू से, इन द सेंस कि you guys are trying to champion responsible energy and go towards drive capitalism towards making people conscious and looking at it in a more wholesome way कि यार हमारा impact overall क्या है society पे, right? So just kind of trying to start from the basics कि यार what exactly is responsible energy as defined by you guys?
Yeah, so basically, I think when the company was started, the whole idea was to work on material science for various applications. उस टाइम एप्लीकेशन भी फिक्स नहीं था. दिस वाज
Hmm.
2016 ऑड. तब ये था कि जो भी मतलब इट वाज जस्ट कि एक हार्डवेयर कंपनी बनानी है, मटेरियल साइंस पे काम करना है, फंडामेंटल रिसर्च कंपनी बनानी है. करते करते वी स्टार्टेड इन द फिल्ट्रेशन डोमेन. देन वी रियलाइज्ड यार एनर्जी इज सॉर्ट ऑफ अ गुड एप्लीकेशन टू टारगेट बिकॉज इट विल डेफिनेटली, एंड दिस 2018 we realized it will be a good problem to solve in the coming years. उस time it was just on the brim of someone realizing कि it's a mistake, it's a problem, etc.
Hmm.
So tab when we looked at energy, we looked at it very holistically. We didn't just looked at it as an opportunity. Opportunity थी because energy transition आ रहा था, but there was also uh, a lot of ways of how you could solve energy. तो that was where we realized कि यार अगर energy solve करनी है, then has to be a fundamental principle based on which we'll solve it, which also has to justify why we are doing it. It just can't make economic sense. क्योंकि अगर आप एक सोलर लगा देते हो तो सोलर लगा के इकोनॉमिक सेंस तो सीधा बन जाता है क्योंकि आपका कॉस्ट कम हो ही जाता है बिजली का. बट इज इट रिस्पॉन्सिबल, इज इट एक्चुअली सस्टेनेबल, वॉज वॉट द मंत्रा वॉज. अब एक्चुअली सस्टेनेबल, अगर आप इफ यू लुक एट इट, देयर इज अ टर्म ग्लोबली कॉल्ड ग्रीन वॉशिंग. It's quite a famous term now. Green washing में क्या है कि if you see uh, a lot of companies focus on sustainability and clean energy without even thinking of the negative impacts. A lot of times it has negative impacts, in fact, on climate overall. If not even negative, then मतलब बहुत सारे तो मतलब बहुत would be neutral, that they would not help any sort of impact on climate change. A lot of them would even be negative. So वो ग्रीन वॉशिंग का, and it was all perception. This was major big MNCs, oil companies, etc., who were pushing, who actually had the reason for climate change, and then saying कि I will transform energy and I will transform the world for everyone, which was more of a perception thing. The way they were looking at doing it was actually not sustainable as well. So that's where we said, okay, if we'll solve for energy, we'll solve it in a way which makes a lot of sustainable sense. Triple bottom line. मैं जब ITC में था, I learned a term called triple bottom line. That if you're working on something, it just can't be an economic bottom line. It has to have a triple, which is a social as well as an environmental impact. So the idea is that responsible energy, it should help someone socially, and also definitely be environmentally positive. If economic to sense banna hi chahiye, because capitalism can't, matlab, has to be there if this has to grow and scale up. So this was the whole concept. And how we do it is, for example, our thesis behind it is the batteries. If you look at the batteries that we started targeting, there is a lot of this know-how in the market, and you'll realize कि a lot of people say कि yeah, batteries are far more polluting than normal IC engines as well, because उनको बनाने का जितना emissions होता है is pretty high. So bomb emissions are high in batteries. It is definitely out there because mining से लेके, sorry.
So I was just asking वो term अभी you use some term ना, what emissions did you say? Bond
Bomb
emissions.
emissions. That is bomb
Okay,
emissions. So basically, बिल ऑफ मटेरियल एमिशन, जो बनाने का
अच्छा,
मैन्युफैक्चरिंग एमिशंस होता है, सो दैट कॉल्ड बॉम एमिशंस.
गॉट इट.
सो वो बनाने के एमिशंस काफी हाई होते हैं, आपको माइनिंग वगैरह से लेके एवरीथिंग दैट यू पुट इन द मैन्युफैक्चरिंग एमिशंस एंड ऑल आर देयर.
हम्म.
So it makes sense. Matlab, bomb emissions are high in a battery pack. So until and unless you use a battery for high number of kilometers in a day,
हम्म.
and the battery is supposed to last for a long life, because look at it कि आपके पास IC इंजन है, आपके पास बैटरी है.
हम्म.
तो के केस में, बैटरी के केस में इलेक्ट्रिसिटी यूज हो रही है, IC इंजन के केस में पेट्रोल डीजल यूज हो रहा है.
समझ गया.
पेट्रोल का एक रनिंग एमिशन है विच इज टेल पाइप एमिशंस, प्लस इंजन को बनाने का एक वन टाइम मैन्युफैक्चरिंग एमिशन है.
हम्म.
बैटरी के केस में रनिंग एमिशंस इज इलेक्ट्रिसिटी एमिशंस विच नॉनदलेस रिन्यूएबल हो रही है धीरे धीरे ग्रिड, सो दैट इज हैपनिंग, सो दैट इज नॉनदलेस ऑफसेटिंग दैट. बट
हम्म.
एक मैन्युफैक्चरिंग एमिशन भी है.
हम्म.
अब अनलेस, सो व्हाट वी हैव टू लुक एट इज, जैसे इन एनी केपेक्स सॉर्ट ऑफ टर्म्स, कैपिटल एक्सपेंस में एक डेप्रिसिएशन का टर्म होता है कि मैं कितने लंबे टाइम तक इस को डेप्रिशिएट कर सकता हूँ. माई अपफ्रंट एमिशंस, जितने लंबे टाइम तक मैं डेप्रिशिएट कर पाऊंगा उतना वो वाला टर्म छोटा हो जाएगा इफ आई एड दीज टू एमिशंस अक्रॉस द लाइफ साइकिल. दिस इज कॉल्ड लाइफ साइकिल, LCA, लाइफ साइकिल असेसमेंट
समझ
ऑफ
गया.
एमिशन.
हम्म.
अब मुझे अगर LCA करना है अपने एमिशंस का, माई रनिंग एमिशन प्लस माई मैन्युफैक्चरिंग एमिशन डिवाइडेड बाय द टोटल एनर्जी डिलीवर्ड
हम्म.
should be less. तो बैटरीज, व्हेन वी लुक्ड एट बैटरीज वर बीइंग ओनली यूज्ड फॉर 3 years, मतलब लाइफ ही नहीं थी 3-4 साल से ज्यादा. यू लुक एट 2 years 3 years बैक, यू वर गेटिंग बैटरीज व्हिच वर वेरी शॉर्ट लाइफ.
हम्म.
So your bomb emissions divided by life was pretty high.
समझ गया.
So we saw a good opportunity in solving this problem, that we'll create a battery which lasts for 20 years. So there were certain chemistries globally which were doing it,
हम्म.
titanium based chemistries, etc. So we said we'll adopt those chemistries. We'll not go behind those chemistries which are only 2 years, 3 years utilizable. उस
समझ गया.
बेसिस पे मेरा बॉम्ब एमिशन कम हो गया. सो दैट इज वन वे ऑफ डूइंग रिस्पॉन्सिबल एनर्जी. सेकेंडली वी रियलाइज कि यार आपको अगर tailpipe emissions are nonetheless in IC engine higher than your battery emissions. But अगर आपको, if you have to have a drastic impact in emissions, you need to run your vehicle a lot of number of kilometers in a day. So we took call कि यार we will only run the vehicles, or we will only target those vehicles which are in the commercial sector, because वहां पे दिन का 100 किलोमीटर 120 किलोमीटर चलता है compared to when you have a private use case vehicle running for 20-30 kilometers a day. So your tailpipe emission का भी offset in a year जितना मेरा एक 3 wheeler या फिर 4 wheeler ट्रक कर देता होगा, in personal use case एक गाड़ी को करने में 3 साल लग जाते हैं उतने emission offset. So
समझ गया.
now globally you have limited lithium, you have limited resources to make or to target climate change, and you have limited time as well. I would rather put all of that capital and resources in an application which gives me much more emission offset today than any other.
हाँ
So
भाई.
yeah, that's
या.
that's responsible energy. That is our thesis behind this. So that will go behind applications which actually are sustainable. That is one. Technologies which actually make sense, which are sustainable across life cycle, and they're not just EV for the name of EV. Third, we also realized safety was a big parameter. So people were just bringing in chemistries, bringing in technologies from geographies जहाँ पे वो China, Europe. So let's look at it. China, Europe, etc. are very different economies than ours. Our terrains are different, our weathers are different, adverse climate, etc. You can't just bring in a tech and try putting it in these geographies, क्योंकि electrochemistry works in very different way in different conditions. एक battery के अंदर की chemistry would be, some chemistries are resilient towards very high temperature, some are not. So just because Europe is a performance vehicle market, you can't bring in those chemistries just because of performance in India. India needs endurance.
Right.
So that's where we realized that safety would be a big part. That's why you saw a lot of fires, etc., happening in India in EVs, because people were just bringing chemistries from countries like etc., which were relatively colder climates, not that adverse, and putting it in India. We said no, we'll bring in chemistries which are more temperature resilient. So something for the tropical belt.
Got
So
it.
that's another way of saying we are responsible, in a way that we're responsible towards society. So it's not only climate, but also impacting that. So secondly, I think the social bottom line is, because we work on the commercial EV segment,
हम्म.
a lot of the impact is at the last mile or the grassroots level of drivers who run these vehicles.
Right.
So that by actually transitioning them to from IC to EV, you increase their income overall. So their income increases because their savings are much more. They spend much lesser on EV. Then secondly, matlab, if you look at it very nitty gritties, IC engine based auto, etc., you would have seen the gears, right?
हम्म.
Think of it, someone running 120 kilometers a day, the number of times he would be clicking his hand just to change the gear.
Right.
EV, there's no. That in itself has such a big. If someone does a impact of life cycle of health impact of someone sitting on an IC engine auto versus an EV auto, humongous.
Right.
So I have like a couple of questions
Yeah.
based on what you said, Kartik. So isme you mentioned, first of all, like you mentioned performance vehicles and endurance use case, performance versus endurance use case. Can you sort of help us understand that better? Like
Yeah, sure.
what do you mean by those two things?
So let's suppose so chemistries are different. So a chemistry, for example, in lithium would be something which has a high energy density and high power density. When I say high energy density, lambi range ja sakti hai itne se area mein. So if you put this much of a battery pack, it will give you much more range, much more energy. Now, Europe, if you look at it, China, if you look at it, it's a highway driven terrain. The roads are highways and then there are exits. So things are at distance, so you need high range. So plus people a lot focus on high, and because it's lesser traffic in those areas, even in last mile internal cities, your accelerations are higher, your top speeds are higher. India, to be honest, if you look at it, हम लोग बैंगलोर में 30 की एवरेज से ऊपर नहीं जाते. मतलब वो भी बहुत ही बड़ा एक वो है 30 में भी if you're running it, it's also very मतलब you're in a good area in Bangalore. So 30-40 से एवरेज मेरा ऊपर जाती नहीं है स्पीड. I don't have highways I have to run. So I should rather so जब आप ये when you look at high energy density chemistries, usually they come at an offset of or at a trade-off of safety. They come at a trade-off of life. So this chemistry is called a nickel and a cobalt based chemistry, जिसकी वजह से लोग कह नहीं रहते कि cobalt कम हो रहा है, cobalt is lesser, there is rare cobalt in the world. So cobalt based chemistries were the ones which were endorsed by Europe, US as well as China a lot initially. China now shifted towards iron based chemistries, which we also focus on. So cobalt based chemistry में challenge ये होता था कि your range is longer. It's a smaller battery, so you can put it in a performance vehicle, and small vehicles get higher acceleration, but life was very limited, 1000 cycles, 1200 cycles, etc. So that was where we focused on iron based chemistry, जहाँ पे endurance ज़्यादा है, life is ज़्यादा है, performance थोड़ी कम है, your energy density takes an impact. जहाँ इसके बजाय I have to put a relatively bigger battery, but then that's fine. I have enough space in an auto to put it up. My cost should be relatively lesser, my life should be longer. I might not need a very strong acceleration for sure. मतलब उतनी तो यहाँ पे जगह ही नहीं है करने के लिए. So that's the trade-off I was talking about.
Got it. And I mean, जिस तरीके से तुमने responsible energy समझाया, that is also like very fascinating in terms of the triple bottom line. And I couldn't help but wonder जो energy effectively store भी हो रही है बैटरी में, like उसका production और उसका distribution, because like a chief criticism around electric vehicles, अभी मैं US में Senate hearings भी देख रहा था इस topic पे, which is about कि मतलब अभी do we have the infrastructure to support electric vehicles en masse? I'm not sure how does that translate in the Indian context right now. So can you sort of touch upon key energy production, distribution, storage is across this whole gamut? Responsibility कहाँ lie करती है? Like what are the dimensions to think of?
Okay. So if you look at it currently, the whole India is taking a stand towards renewable. So countries globally have taken some stand towards clean energy. For example, France is more nuclear. Certain countries are more renewable. India is one of the more renewable focused countries. Renewable has its renewable definitely is clean. There is no question about it. It's solar, you're converting into electricity and transmitting. But the challenge that comes is renewable is also intermittent. There's only a time period when you get renewable. If you have to get it across the day, that's a challenge. So you need to store it somewhere. So that's where battery technology is important, because if you see our demand supply curve, so thermal कैसे चलता है? Thermal is a very good flexible fuel, to be honest, in thermal power plants. Coal आपने डाला, but it's still not that flexible कि आप उसको हर घंटे चेंज कर पाओ. आपको एक दिन का लोड डिफाइन कर देना होता है. It's a 24-hour cycle. अब what is happening is, so these are two thought processes. A lot of people, and I also am a believer a bit in there, that we should have gone nuclear. It's more flexible as a fuel. You can match your demand supply. Your demand supply is not constant, right? Your demand is not constant across the day. There's something called a duck curve. If you ever see the demand curves across a day, there is something a very interesting concept called duck curve, कि एक particular 3 घंटे 4 घंटे का बैंड होता है जब वो बिल्कुल नीचे ड्रॉप कर जाता है फिर वापस आता है. सो
अच्छा.
क्या हुआ, अब डक कर्व में आप कैसे, अब आपकी बिजली जनरेशन इज नॉट एट द डक कर्व टाइम. सो अब आप पीक लोड के लिए अपनी, अगर आपने सोलर डिफाइन कर दिया, which you have to, if you have to match whatever peak demand is there, because आप solar define करोगे power के हिसाब से, then for the duck curve there will be either extra energy coming out which you need to store and utilize at the night time. Abhi this year itself, if you look at it, India, because was going very gungo on renewable and thermal, it was not increasing, and we're a developing nation, so our electricity consumption is also increasing year on year by 6%. तो जब आपका इलेक्ट्रिसिटी कंजम्पशन बढ़ रहा है, आपने रेन्यूएबल तो बढ़ा दिया, बट आपकी रात की तो बिजली की कमी हो गई ना. सो यू हैड अ 1.7% डेफिसिट दिस ईयर इन इलेक्ट्रिसिटी एट नाइट. दैट्स वेयर it needs a more balanced approach, but then it needs more capital, because renewable में अगर आपको storage डालना है, you need a lot of capital to put in, but which if you look at it, otherwise आपका grid disbalance हो जाएगा, or you will end up having thermal as well as solar, क्योंकि आप
Mm-hmm.
बेस लोड अपना बढ़ा दोगे थर्मल रात के लिए, तो वो भी चलता रहेगा और आपका सोलर तो रहेगा ही रहेगा. So government just last week they took out a viability gap funding for battery storage for grids. So they've just launched that policy because US में already those were being put by states to balance the grid, to balance the nighttime ka bijli ka power requirement. India is now starting to do it. But what we feel is, if we are taking a renewable stand, the better way to do it is put solar plus wind plus battery. Because
Okay.
wind, irrespective of day, also runs at night. There's wind at night as well.
Hmm.
So that's a better way of going about this problem altogether. Put up solar plus wind plus battery. India has a good transmission network, so make it transmission free. You have to be very smart about the grid. So I won't have solar plus wind at the same place. So I
Understood.
might be putting a wind at a place like Karnataka, and I might be putting solar in Rajasthan. But then someone needs to plan this across the country. My demand supply across the country has to be mapped. It's like, look at, to be honest, we look at electricity as FMCG. The transmission network is your distribution network. Your substations are traders, and your generating plants are your factories.
Hmm.
So
Makes
you
sense.
have to look at the country as that sort of network. All your cable lines, etc., are nothing but logistics, which is
Hmm.
carrying that current from one place to other. Now, if now any FMCG company also works in that way only, right? They have a factory, and then there is a distribution network across the country, and then there's inventory holding at different places. The inventory holding will be your battery storage.
Right.
Uh, you can't have in a tier two city a lot of inventory holding; it will go to waste. So you need to plan it very well. But then it needs a very pan-India sort of coordination to plan this out. So
Mm-hmm.
that's where we will be able to attack the duck curve to have consistent clean electricity across the day without the need to increase thermal load. Otherwise, what other thought process is that you will end up increasing your thermal load as well.
Hmm.
Hmm.
Base
I
load will
see.
keep on increasing for you.
And how does it work on the grid side? Like, so when you're talking about renewable, तो क्या पूरा grid infrastructure you need a separate, a parallel grid infrastructure to the thermal one, or you can possibly load and
You
store
can use the same one. So
energy?
basically, because the complete current electricity is thrown AC even in renewable. So AC you can transmit anywhere. So it's common currency.
Okay. Okay, got it. And I think I also noticed कि अक्षय का एक इंटरव्यू था where he mentioned कि ये battery swapping network is possibly not a good option in the long run because again battery का जैसे तुम कह रहे थे कि इसका bomb emission high है, it's not sustainable to produce a lot of batteries and you need like more battery infrastructure, more batteries just to swap this. तो but again I think there is industry में इसके around भी disagreement है. So will help अगर आप battery storage मतलब storage solutions पे भी बात कर पाओ.
There are two thought processes. So what we feel is battery swapping came into being because fast charge was not there. Battery swapping ka advantage is you get the refueling time period, etc. But the challenge was, so India mein fast charge didn't come into being before Log9. Log9 was the first fast charge company in India. Before Log9,
What is fast charge exactly? Sorry, just a
yeah,
leeway.
so we divided. So this was also nomenclature we had to redefine. So we said anything lesser than 1 hour of charging is fast charge. Anything greater than 1 hour of charging is slow charge. And even anything lesser than, let's suppose, 20 minutes we feel is rapid charge. So we brought in rapid charge.
अच्छा.
So our products were rapid chargeable. So less than 30 minutes or anything is rapid charge because it's just boosting money. You take your lunch, it's done. So
Hmm.
that's how we were doing it. Now rapid charging requires technological innovation at a battery material level itself. It was never a problem of grid. A lot of people used to think that we don't have enough power to power charge battery packs at the charger level. No, even if you had push in faster, let's know what we did. You had Mahindra E-Veritos, right? At that time, we were one of the first EV cabs in India. E-Verito used to have a 15 kilowatt bigger charger to charge it. Now, E-Verito will have a bigger battery pack. So it used to take 2 hours, 2.5 hours to charge Mahindra E-Verito, 2 hours to charge using that fast charger. We used to call it fast charger because 15 kilowatt bigger charger.
Hmm.
Now that power is enough if I power a two-wheeler which has a much smaller battery pack will be able to charge pretty fast if I connected the same charger. But
Hmm.
people were not doing it. And the prime reason was because electrochemistry, when you charge or pass so much higher current from a smaller battery pack, which the chemistry can't take up, it'll explode. The ions will move very fast, etc. There'll be plating, dendrite forming, it'll explode there itself. So that's where we said and chemistry solving is not an easy task for sure. It is a difficult task compared to an operational innovation which you could have done, which swapping guys did. They said, okay, I'll move the batteries out. We feel the moment fast charge happens, you don't need swapping at all, which is now the new wave. If you look at it, there was a lot of noise around swapping in 19, 20, 21. After 21, now there's a lot of noise around fast charge and rapid charge globally. If you look at it globally, companies are talking about fast charge, rapid charge, but be it battery companies, be it OEMs, everyone is talking about as fast a charge as possible. Tesla never adopted swapping. If you look at it, Ether never adopted swapping.
Hmm.
So people who are, yeah, think of it. Automakers make a vehicle. A vehicle is nothing but a very beautiful integration of multiple mechanical and electrical components. It is the most beautiful amalgamation. Everything works in sync. Any one bolt even goes left and right, it's a disaster.
Right.
So I come from a chemical background, but for me, if you ask me, automotive is the most cross-functional and the most beautiful product built till date because there's so many moving parts. So think of it, you're replacing the heart of it every now and then. How will as a automotive or an engineer I would even allow that?
Hmm.
I would
Correct.
say, boss, and that used to happen. A lot of time the sockets used to see, human experiences or human nature of using or doing that is very diverse. Drivers used to just put in the battery pack so aggressively socket toot jata tha.
Hmm.
Small things like this impact safety drastically. That is on the safety side. Economically, the only country I'll say where swapping has been successful is Taiwan. Taiwan, there's a company called Gogoro, which did pretty well. But Taiwan what is the size of Taiwan? Look at India. It's a massive, massive country with so many diverse applications of automotive. You have two-wheelers, you have three-wheelers, you have e-rickshaws, you have four-wheelers, trucks, you have passenger four-wheelers, you have commercial two-wheelers, you have private two-wheelers. It's drastic applications. It is very difficult bringing and swapping only works when there is a lot of standardization, so that there is more cross utilization of assets of battery packs, so that your total number of float batteries remains less. And what is a float battery? The total number of batteries that you keep per vehicle, because one will be inside, part of it will be outside. So the magic number is 1.3. But reaching 1.3 in such a diverse geography with so much diverse applications, it will be usually. So we feel swapping companies do create some value in terms of experience of consumers, but do they make a capitalist sense for it to scale up by themselves is a question. And that's why you see a lot of these companies closing down globally. Israel had one company, reached $1 billion valuation, went zero. China, a lot of swapping companies died.
Hmm.
So not that
So,
easy because managing at scale is difficult.
basically, if I understand it, just trying to encapsulate कि battery swapping effectively, what I understand, and please correct me if I'm wrong, is कि आपने, let's say मेरे पास एक EV है, and I have one battery pack which is currently installed, and then there is an alternate one which is probably getting charged or is charged. once the one in my vehicle gets kind of exhausted, I replace the already charged battery and then put this to charge. This was battery swapping, and effectively, if I look at it this way, it's like a बार-बार हार्ट ट्रांसप्लांट या some kind of transplant कर रहे हो, तो
100%।
obviously कहीं
या
पे
फिर आप आईसी इंजन में अपना फ्यूल टैंक रिप्लेस कर रहे हो,
हम्म
आप कह रहे हो ये रहा मेरा पुराना फ्यूल टैंक, मुझे नया फ्यूल टैंक दे दो,
हाँ and
नॉट
तो
नीडेड।
things can basically very easily go wrong
करेक्ट,
in that process itself.
करेक्ट,
Makes sense. So hence I think this fast slash rapid charging is which the innovation which you guys are kind of working on,
मार्केट
and
विल
obviously
ड्राइव दैट, या।
hmm makes sense. समझ गया.
Uh,
Aishwarya, you.
Yeah, I mean, I think next I want to touch upon जो आपने एनर्जी की रिक्वायरमेंट इंडिया की बताई थी. ओवरऑल एनर्जी रिक्वायरमेंट इज ग्रोइंग इन अ डेवलपिंग कंट्री, एंड what is the current sort of balance between thermal and renewable right now? Where do you see it going? And yeah, I mean, and this whole hype around making India energy independent. Like, what is the vision for that? How do we make that happen? I think that's something where we can go
And I
next.
think just adding on to this, I think I was also looking at a podcast where Amitabh Kant was there. Abhi the Ranveer show pe Amitabh Kant was there like last week itself. So he was also mentioning कि in मतलब the most money making kind of sectors for India in the next 5 to 10 years would be he had named 4, which was hydrogen cells, semiconductors, e-mobility, and I think one more was there. And e-mobility में another interesting which kind of made sense to me was कि काफी nascent है अपन, मतलब right now there are only 22 cars per 1,000 people in India, versus if I look at the US it's around 1,100 cars per 1,000 people. So the mobility sector in itself is also kind of picking up. So like how so वही थोड़ा बहुत समझना है इसी के around. Can you expand on this कि like why is it the most money making, and मतलब how are we placed right now, and where is it heading to effectively?
Okay, so starting with the thermal is to renewable, I think we've reached a 30 to 35%, 30 to 40% somewhere as a share of renewable versus thermal. Still, I think we'll need a fact check. The last time I checked, it was this. The target is to reach, people say 100%. I don't feel 100% is possible at all. You will need a base load. So a base load in India, so US is gas based, ours would be coal based for sure. So there'll be a base load, and then there'll be solar, wind, and I think 2030 would be a good time period to check this number. In my opinion, it will be anywhere around 60% odd. So the way it's expanding. So that is your grid mix, a grid mix of energy that is coming in. Then in terms of becoming energy independent, yeah, it makes us energy independent because coal also we import at times because of scale of India. Putting up solar. So a lot of people say even for solar, we have to import solar cells, right? Even for EVs, we need to import lithium, etc. So but think of it, continuously importing oil every time you have to run your vehicle or you have to run your appliances at home, versus importing a one-time machinery and then using it to deliver energy across life. Very different. The thought process needs to change a bit. Your imports will definitely cut off of oil the moment you shift towards these technologies, which is either solar, EV batteries, etc. The moment you do that, there'll be import for sure. You can't shy away from it. If we had to shy away from it, we should have invested in these technologies 10 years back itself. So we did. So you can't have everything. So that's I think where we lack, that at times when something becomes important, we want all of it. We missed the semiconductor bus. We missed the solar cell bus. We didn't hop onto, and China won, very frankly. Even in lithium, China won. We today, Log9 is the biggest cell manufacturer in India with the 50 megawatt hour line. We're still minuscule in front of China. So either we should have pumped a lot of money from government and PSUs into this industry 10 years back and would have taken a 10-year vision wala bet. Otherwise, that can't happen. So there'll still be imports for sure. The imports will be more around solar cells, will be more around lithium. And then the cell manufacturing, etc., module manufacturing will happen in India, which will give you energy consistently, which is independent. And it will be an oil offset. So that's how this energy transition will happen. One technology innovation which might even cut off the lithium thing would be your sodium. So a lot of work is also going on sodium cells being made. If sodium is made, then you don't need lithium. Though lithium reserves are also being found in India, which is a big positive for us. But it still needs to open up. It will take some time for sure, looking at how we move. So that's where we are. Um, Now coming to your question around the how it's a rising sector for sure. If you look at it, the previous decade, 2010 to 2020, was more around e-commerce, apps, website, digital tech. India was a digital tech, fintech. This decade is more around climate technologies, hardware technologies, robotics. Because now we're in because there's always that curves have always come in, right? So some transition happens, and then there'll be softwares over the top of it. So I'm
Obviously.
not sure if EV will be a complete hardware innovation. It'll be a hardware innovation and then software. Connected mobility will be a big thing after EV. If you look at it, if someone needs to work on something from now, not on hardware but on software, electric mobility will be the next thing, because connected mobility will be pushed through the rise of IoT as well as EVs, which is a smarter vehicle.
Connected mobility क्या हुआ exactly? थोड़ा सा if you can define that.
As simple as so smaller applications, I'll tell you. Abhi, if you go to a charger, public charger, you have to go scan, etc. Why to do that? You simply take your vehicle. There's a Bluetooth already inside the vehicle because there is IoT inside the vehicle because it's a controller-driven vehicle rather than a mechanical-driven vehicle. It's an electrically driven vehicle. It's like a mobile phone.
Hmm.
You take it up, you connect the charger. You don't have to even talk to anyone, and it automatically identifies, debits your Paytm wallet, and it's done. Think of that. So that is what the future is. I go into, for example, I go to the drive-through of McDonald's. My car automatically connects to the POS system there, does a debit. I just tell him what I have to. It's like a tap. Your car is the tap.
Hmm. Interesting यार, काफी cool.
So
Got it.
connectivity will be a big thing.
Hmm.
There's a lot of things already happening in that front. So that's when people say electric mobility, it's not just electric vehicles, it's also connected mobility along with electric vehicles. More communication between vehicles, logistics systems, consumer systems, like one that I talked about, parking systems, etc. That is happening. Hydrogen will be another, but we're still not sure. We need to see the capex of hydrogen to come down. It's
Hmm.
still a very high cost product because of simply the catalyst cost being high. So that innovation is still happening. People still have to innovate a lot on hydrogen, in my opinion, currently in the fuel cell domain for it to be successful. So it'll still take some time. It's still a niche application, in my opinion, for Europe, etc., where there's capital available. In India, in my opinion, the first electric mobility will be around last mile, where you don't need a lot of range, so you don't need a fuel cell. The second wave will be for trucks where you might need a fuel cell. But that too, in my opinion, will be divided into two chunks. One will be middle mile or applications where the routes are fixed, so you can put a battery and do it. The phase after that will be no dedicated route, random routes where you need a fuel cell because you need a longer range, a much longer range, and you don't need to go to a charger. You can refuel it like fuel.
Hmm.
So that's how electric mobility will transition. The first, but the biggest market right now, and which continues in the next 5 years, is last mile. Your intra-city deliveries, your intra-city movement, mobility.
Got it. And मतलब अभी this is more mobility from a commercial standpoint more and not from a consumer standpoint, so to say. Got it.
Well, it makes sense, right? अगर आप जब आप commercial applications के लिए solve करते हो, you solve economically beautifully. Because you run 100 kilometers a day, even if your vehicle cost is a bit higher than IC engine based vehicle because of scale not being that high today, as you rightly said. Even in three wheelers, we're what? One out of every five three wheelers sold is today electric. So four are diesel still. So that scale and this scale is still lesser. So your cost is definitely higher a bit. If your cost is higher, your capex is higher. But if your running is too much, your lesser OPEX justifies that cost pretty fast. Your payback is pretty faster. So economically beautiful. Sustainability no-brainer. Then third is infra. Setting up for a commercial mobility, infra setting up is much easier because there's more predictability. I know that a two-wheeler delivery will go to this restaurant, or this restaurant is a hub for a lot of two-wheelers to come for Zomato, Swiggy. I know this area, which is a area of warehouses of Amazon, Flipkart, Myntra, I know three-wheelers and four-wheeler trucks will come to pick up luggage here, to pick up a load there. So it's easier for me to set up a charging infra based on these predicted tomorrow. Then once this is set up for a dedicated routes it's set up, the infra then can be made open to private sectors. If I start in the reverse manner, start setting it up for private sector where there's no predictability, my capex and the capitalism part of it takes a hit. It's then NGO, it's then more impact than actually any returns. I don't have predictability of either. Will my consumer come here tomorrow or not? I don't know. But a fleet vehicle for sure comes every day because it's a revenue, it's a productive asset. It's not an ambitious or a luxury asset like a private use case vehicle. It's a productive asset. It has to run every day.
मेक सेंस. हाँ मतलब आई थिंक देयर इज आल्सो दिस, जस्ट ट्राइंग टू ड्रॉ काइंड ऑफ इन्फरेंस. जैसे बैंगलोर के आउटस्कर्ट्स पे देयर इज दिस नीलमंगला वाला जो पूरा साइड है, वहाँ पे काफी सारे वेयर हाउसेज हैं इन जनरल of all the different companies, so it definitely makes sense to start setting up the infra there. And मतलब ऐसे hubs को target करोगे तो obviously you have
Hub
a
and
more
spoke.
predictable.
You start doing hub and spoke. You target hub and spoke,
Hmm.
set up infra for hub and spoke, and then make it open for everyone else as well.
Makes sense. Makes sense. इस पे ऐश्वर्या, do you have anything to ask or add?
मैं अभी तो रिसोर्सेज के पॉइंट ऑफ व्यू से ही, जो अभी हम लोग बात कर रहे थे कि इंडिया का एनर्जी इंडिपेंडेंस, यू मेंशन कि कोल इंपोर्ट करना या ऑयल इंपोर्ट करना, कोल तो नहीं, ऑयल इंपोर्ट करना वर्सेस लिथियम इंपोर्ट करना, एंड लिथियम को आप मल्टीपल यूज बार बार यूज करते रह सकते हो. आई थिंक देयर इज अ यूज केस फॉर there is innovation happening on the recycling side as well to use lithium over and over again. Just wanted to again, from materials to technology, if you can comment on कि अभी इंडिया की एनर्जी इंडिपेंडेंस कैसी है, what is the context or relevance of the newfound lithium mines in Kashmir, for example, and in terms of the technology transfer, like अगर बैटरी मैन्युफैक्चरिंग की भी बात करें तो what amount of technology or R&D expertise does India have already, yeah, has the potential to develop, versus what needs to be insourced from other countries or other companies around the world?
So I'll answer the last question first. So if you look at it, technology for sure, there was a big dearth. We at Log9 we have what 120 odd R&D engineers, out of which 50 to 60 are in cell manufacturing or cell development, and 50 are in battery packs as a system. A lot of them, in fact, most of them are homegrown. They're grown inside Log9. They have learned here because there's not much talent available in India who has worked on this. It's very limited number of companies, very limited of know-how. And so we also try to drive parallels from other industries. Just as any new industry, you drive a parallel. For example, if I have to do coating of cells, I might draw a parallel from paint industry, maybe. So that's what you try, but it's still very difficult. Electrochemistry was not we started in the most premier colleges of whatever. I was a chemical. I never even, there was not even lithium as a word in my 4 years of BTech. So I think it's something that now people have realized it's coming up. So I'll say a lot of it is also reverse engineering. We're also following, the complete country is following the China thesis now, to be honest. It's learn from others, learn how they do it, break it up, understand, and then set it up. But where we are better a bit from China is that we're not very stupid in reverse engineering. We also put in our heads in between to see how can we make it better for the place we are living in. That's how I think we're doing it, and that's, I think, would be almost the complete industry today in India. We ourselves, for example, Amaraja is an investor. We've licensed, we've worked with them for a particular technology that they'll be scaling up in terms of cell manufacturing. Now that itself, to be honest, Log9 and Amaraja itself is one of the major shareholders of this complete industry of cell manufacturing. So, and that's why if we speak for us, then we speak for a lot of other companies as well. So that's why companies are taking either two routes, something like us, which is homegrown, get in things, start working on it, etc. The second is your JV route, which was always that India worked on in the automotive. Automotive was always a JV driven thing. Indians started by, so for example, you pick up any company in India was a JV with some global company, Maruti, Suzuki, and all of that. So, but there now what has happened very interestingly is that at that time, Japan and US and Europe had a lot of technologies during the automotive industrial revolution era.
Correct.
This time it's all China. So politically, it is becoming a bit difficult for people to go to China and do a JV. 20, 30 years back, for other revolutions, you could go to Japan because, okay, you are better. You have a better understanding, better relationship. You could go to US, better relationship, more transparency in the value chain, and you could do a JV, bring in technology, scale up manufacturing for the masses that are there. But now the whole technology is with China only because of their work on it 15 years back. Now, good for them, but for also what has happened is all this political sort of biases that has happened globally now. People are looking at either homegrown or trying to find other research labs to work with. So that's why in India, you will still see a lot of people have not done it very fast because every company is otherwise putting up a cell plant today in India was pretty easy, right? Go to China or go to any other geography, do a JV, set up a plant, invest money, and it's up. But do you go to China? Do you go to a Chinese manufacturer, tell him, boss, we're in a 50-50 partnership today? It's a very difficult conversation to have. You've not seen a lot of China JVs before. We didn't hear about China JVs, right? We heard of Chinese companies entering India in the mobile phone sector. But rarely we heard a Chinese JV with an Indian major conglomerate and then doing something.
Yeah, there was this Foxconn Vedanta thing happening, but that didn't work out.
And Foxconn, I even call it a Taiwanese company rather than a
Taiwanese
Chinese
company. Yes,
that,
yes, makes sense.
There's still that arm's length in between. Now think of it's all in China, like heart of China. So that's where the gap is that, people are also contemplating how to go about this problem of where the technology will come from. But now I think companies like us have developed technologies. Certain research labs in the US have developed those technologies. Certain companies in Europe have developed technologies and set up those giga plants. So I think JV sector will also JV route will also be one of the major routes of how people will go about this technology transfer that will happen. But it'll be interesting to see how many of them would open up Chinese gates and how many would be non-Chinese gates.
Makes sense.
So that's on the technology bit. Sorry, I forgot the question before that.
Yeah, the other thing was about the materials side of it, like lithium mines being found in Kashmir, and also like about China itself. Like I noticed that I think it was about cobalt, that almost 95% of the world's cobalt is in DRC and maybe northern Zambia, and about I think 80 to 90% of those mines are being operated by Chinese. So like they do have a good stranglehold on the minerals itself. So in terms of minerals independence or sourcing them, like what do you see happening in the industry?
Cobalt was definitely a problem in the supply chain. So cobalt usage has gone down. Chemistries have innovated on cobalt being lesser. NMC was the chemistry which was cobalt dependent. So any performance vehicle to an extent will have a cobalt. But now there was this, and again, China only innovated on that. China brought in a chemistry which was an iron-based chemistry. So it doesn't have cobalt at all. It's all iron. Iron is cheap. It's iron phosphate. It's called LFP, lithium iron phosphate. So it's iron and phosphorus. So that almost everyone has. So that has brought in some bit of non-dependency on cobalt for sure. And India definitely will take an LFP route. A lot of companies in India will take the LFP route just because of no cobalt dependence. And safer. Iron chemistry is safer. The only downside it is bulkier a bit. It will have energy density maybe 15% lesser. 15 to 20% lesser than an NMC. So that fact, I think, in my opinion, we should be ready to take, looking at the pros of no dependence on, the other geographies for cobalt, the very tight geographies where you get it from. Lithium is still distributed at a lot of places. Cobalt is very concentrated. So that makes sense. Second, safety makes sense. So I think we will continue focusing on more iron-based chemistries to de-risk cobalt. Now, coming to lithium, yes, reserves have been found. I think we would be able to, but it will take some time for those reserves to actually be actual mines and then processing. So it's not just lithium mining, then there's a lot of processing. So today, the challenge, to be honest, globally is not available of lithium resources with friendly countries. The challenge is actually 80 to 90% of that processing is with China. So even if you find a lithium resource in Australia, it goes to China, processes, and then comes to Europe, etc. So again, that first mover advantage, beautiful how China played it. So I think today with this mine coming in, but for sure because of government's push behind it being independent, and definitely with the current government, there'll be companies which will set up processing in India. We might not be able to, or we might be, but let's suppose we were not able to get those reserves converted to mines by then. Still a lot of countries like Australia has a lot of lithium mines.
Hmm.
So, and we have good relations with Australia. So
Hmm.
your results will be solved for your your lithium will be solved for, in my opinion, by setting up processing in India first, which is the first target which people should look at,
Hmm.
rather than looking at mines directly. Though Indian government is very aggressively working on buying mines globally on the lithium front. That I think is already happening. So we discuss a lot with Niti Aayog, etc. on that direction. There are programs of the ministry to go and buy mines globally on lithium.
Yeah, I noticed that. Cool. I think अभी तक हम लोगों ने इस पॉडकास्ट में काफी, इनफैक्ट मेरे लिए जब रिसर्च करा था मैं, तो मेरे लिए भी वापस पीरियोडिक टेबल का रिवीजन हो गया था ऑलमोस्ट. तो या आई थिंक वी शुड ब्रेक डाउन दी सेल मैन्युफैक्चरिंग टेक्नोलॉजी, एंड प्लस उससे पहले लाइक हाउ डज द सेल वर्क. आई थिंक एकदम बेसिक 101 से चलते हैं कि हाउ डज द सेल वर्क, एंड लाइक अगेन उसकी मैन्युफैक्चरिंग में क्या चीजें लगती हैं. व्हाट डू यू थिंक, यश? डू यू वांट टू स्टॉप फॉर एनीथिंग एल्स बिफोर वी डाइव इनटू cell manufacturing itself?
हाँ, मतलब I think before that, मतलब probably we can and that would kind of flow from the question that I have. So just जैसे Kartik, the way I am able to understand the whole value chain, so to say, right, of this battery wala battery manufacturing wala part is कि there is the first step, which is the research, so to say, right, कि figure out करो कि बनाना भी क्या है effectively. Then there is the procurement of materials. Then there is the production of the cell/battery itself. Then there's an assembly layer, which probably you guys would not be doing it, but the putting of that battery into a particular vehicle, right? That part, and then there's the distribution of that particular vehicle itself, right? So I just wanted you to kind of take a go at key. First of all, how in all of these, let's say, steps of the value chain, and if you want to expand on the value chain a bit more, in all of these steps of the value chain, how does kind of Log9 bring the angle of responsible energy into this, right? And then probably we can segue into the exact the cell and battery composition hota kya exactly.
So basically, the first step where we start is definitely choosing the right chemistries. That's where responsibilities start, which I touch based during the start of the conversation. That choosing chemistries for the tropical climate, safer, with very long life cycle, higher endurance, and secondly also focusing on chemistries meant for commercial sector. So that's where we start by choosing the chemistry, where we have chosen LTO and LFP as two chemistries, lithium titanate and lithium iron phosphate as two chemistries. The next step comes in cell manufacturing. So responsible in terms of nationalist importance, I think there is no point in even talking about it. Putting up a cell manufacturing line in India itself is a big nationalist movement, and hence it is one of the major driving force for us to do it as well. So that's one. But the way of the process of manufacturing, we also have taken certain things there. For example, we've looked at aqueous electrolytes rather than organic solvent-based electrolytes, because organic solvent-based electrolytes, when you waste or it goes out in the air, it's not and if it runs off, it's a polluting material. So we're looking at aqueous electrolytes, which is water-based electrolytes basically, which reduces the pollution impact of cell manufacturing a lot. It was one of the major things that people were looking at globally, but because we were late, so we could hop onto that as our starting bit itself. So water-based electrolytes so things like that we're working on in the process step to make it sustainable or responsible. Then I think third after that, so this is the second value chain. You first choose the chemistry, then you make it. In making also, you start with a very small line. So 4 years back, we bought a very small line, a 1 megawatt hour line, to first learn how to make a cell 4 years back. Then at that time, in fact, we were not even doing lithium. We were doing supercapacitor, because supercapacitor is a dumb chemistry. There is no active materials. It's simply electrons here, there, electrons coming back. So there's no ion movement, there's no electrochemistry, there's no reaction. So we were using that, we were making, but it actually taught us how to make a cell because the structure was similar. So we did that. Then we researched a lot on the 1 megawatt hour line. Then now we've gone to a 50 megawatt hour line, which is a pilot line altogether. It's not even still a manufacturing commercial line, it's a pilot line. Then after that, once you've done that and stabilized chemistry and process there, then you go to a bigger line, a gigawatt hour line. which is a very big line. It will be a gigawatt hour is at least 80 to $100 million in terms of capex of the line. So that's the second phase for us. After that, the value in the value chain is making battery packs. So before even the battery pack gets integrated in the vehicle, you have to make a battery system. A battery system is the OE part of it, is the most cross-functional part of it. So you look at cells which come, then you look at your battery management system, which is a electronics layer and a computer layer on the top of it. You look at wire harnesses, which is conducting that electric current inside. You look at structurally making it, thermal management systems. It's a very niche thing. So Log9, one thing that we did was, before even getting into cell manufacturing, or at the same time, we also got into battery pack assembly. So we currently are much bigger in battery pack assembly than cell manufacturing. Cell is still at a pilot phase, but our battery pack manufacturing is a 500 megawatt hour in terms of LFP, which is 10 times than our cell manufacturing line. So we still import cells. We are dependent on cell imports, but then we do the complete system internally. So the other parts is all indigenous, etc. And then we make those battery systems and we put it in for various OEMs and vehicles. Now, what that helps us is in a lot of insights, which we give to our cell team of how to make a cell which is more fit here. So it was a more downstream first and then going upstream approach. The only thing we did both of them in parallel did cause a lot of burn in terms of capital there, but I think it was well justified, seeing how it was definitely something that had to be done. So battery pack assembly is our next bit in the value chain, and then it is OE integration. So we have a battery pack manufacturing plant in Bangalore near the airport toll. We have a cell pilot facility in Jaipur. So we have two facilities here. Now after that is OE integrations, which happens majorly at OEs, three-wheelers, two-wheelers, four-wheeler trucks, etc. And then it goes to a customer through dealerships, etc., which the OE sets. Log9 also set up a subsidiary company called Log9 Mobility, because we saw that, unlike the previous IC engine segment where the adoption and where the vehicles are owned by drivers, here it is owned by fleets a lot. It's an institution and it's an institutional driven market today. So it is majorly owned by fleet operators, by transporters. So currently we see that the market is a fleet driven market, and it's also the pull is from more corporates or companies who have taken sustainability bets, and specifically driven a lot by e-commerce. So what we realized was, so you remember the digital transformation when it happened, it was 10 years back, it was lesser through SaaS and more through people like SAP, Oracle, and still is Oracle, etc. Because when you have to transform a very manually driven company to a different way of working, it needed handholding. So that's why someone like an SAP, Oracle, etc. used to come and do that handle. And then that is the same thing which is happening today in electrical transformation for organizations. People don't understand EV, to be honest. If you are a logistic company, you say that I have to switch from an IC engine to an EV based operations. That transformation is difficult to manage if seeing the number of people with different intellectual levels working on it. So that's where I think a company like Log9 Mobility was needed, and there's others also in that sector who help them transform by looking at uptime of EVs, the right EVs for the right application, then infra, charging infra, parking infra, etc. So Log9 Mobility is a ecosystem player wherein we help organizations go electric, and it's a primary. So basically, that's how we have created our own distribution. So we're in 26 cities wherein we sell to fleet operators to use our vehicles and then our battery-driven vehicles, and then leverage it in their logistic operations by helping them with charging infra. We have a network of CPOs we work with, charging point operators, a network of charging point operators. We bring them on board, their fleet operators. We bring in financiers also to finance vehicles, because traditionally it was now, because IC engine being a very mature technology, financing is easy. But when it comes to EVs, financing is complicated because each part is very different. How long will a motor run? How long will a battery run? Who is looking at the residual value of a battery? Which recycler is betting on it? What will be the value I'll get 5 years afterwards of my vehicle? What's my depreciation looks like? A lot of open points. So that open points, because of us understanding technology much better, we were the best people to explain it. So that's how we bring that piece also, and that's what Log9 Mobility does, and that's how we have reached a lot of customers pan India. Our primary customers are not drivers. Drivers are definitely the end users, but we have 150 fleet operators we work with. They leverage our vehicles and they run it on various applications like Amazon, Big Basket, ITC, Flipkart, etc.
Fleet operators would be people like delivery or है ना these
Delivery has gone to a point where it's more asset light now. Still not say complete asset light, but it started as a very traditional fleet operators start with assets on their books or leased to them and then they run it. Currently in EV, we have seen a lot of that market coming up.
Acha.
That market has boomed quite a bit with EV because what has happened is there are a lot of these end customers or e-commerce customers, etc., have taken a pledge that they will only give new orders to EV only mobility players, for example. So there's preference or bias because of which a lot of these businesses have cropped up. Entrepreneurs have started that, managing 100 three-wheeler fleets, for example.
समझ गया. Got it. तो ये अपन बैटरी पैक्स है फिर OE integration. OE integration, exactly what is OE?
OEM is basically all your vehicle automotive manufacturers, someone like a Mahindra, someone like a Omega Siki, someone like a Tata 3V, etc. So these are our customers. So they take in the battery pack and then they do integration with the vehicle, which is not only structurally you do once and structurally, and then it's also electronically. So the battery needs to communicate with the remaining parts of the vehicle. For example, for a consumer, it would be, for example, your instrument cluster, which is in front when you're steering. That all data is coming from various parts, battery as well. So, for example, what's the charge rate? What's the charge in the battery left? That is known as a data point. So, all of this is on a protocol. Currently, the major protocol is CAN. CAN is like a communication protocol on which all messages are flown on a CAN bus electronically and then thrown at different nodes. So, there is in a vehicle, if you ask me the number of smart ICs. So what defines a product to be more? The number of ICs which are there. IC basically computer chips. So battery has one, motor controller has one, vehicle control unit has one, instrument cluster has one. So think of it, there are 4 computers in your EV altogether. And all of them are communicating with each other very dynamically.
Very interesting यार. काफी ज्यादा मतलब काफी डेप्थ है मतलब इस पूरे टॉपिक में. आई थिंक देयर इज वी वर जस्ट डिस्कसिंग कि इट्स वेरी डीप एज वेल. सो आई थिंक नाउ जस्ट डूइंग अभी अपन ने जैसे कवर कर लिया कि केमिस्ट्रीज को फिक्स करके फिर सेल मैन्युफैक्चरिंग देन बैटरी पैक, एंड आई थिंक दीज आर द 3 parts where mostly Log9 is focused right now, right? And you have gone into how you guys are trying to be more responsible towards the whole production process, and after that selling to customers. I think that is more or less out of your control, but you would still try to kind of influence your stakeholders there, which
we do. And also,
and also what I understood is ki like matlab driving the consumer adoption or for that matter end user adoption is important for cell manufacturing to achieve a critical scale. ताकि यहाँ पे economies of scale आपके पास आ पाए.
Correct. That's where I think the mobility arm was also needed. Why we built that mobility arm was to create more demand. The more demand that exists, the more our manufacturing scale reaches, and which helps in the complete value chain.
Of course. Makes sense.
I think this is the common theme across every kind of conscious brand, so to say, or conscious product, so to say, where you have to kind of have an awareness arm, so to say. Yaar, matlab, there has to be a certain awareness created, and also people have to be bridged towards that, and then probably the adoption even happens, because otherwise it's not very super clear on the top of your head.
How I call it is basically people need an ecosystem to consume something. Be it anything. For example, you think of it when nutrition products were coming out there was a complete ecosystem of dietitians which came up.
Right.
No one used to hear dietitian till the point nutrition brands started coming in the market. And now nutrition brands coupled with dietitian is an ecosystem a consumer can consume, which helps the FMCG player also push the nutrition product.
Right. Makes sense. कूल. आई थिंक वही तो फिर अभी अपन ने वही काफी सारे ब्लैक बॉक्सेस में बात करी कि सेल बनता है, बैटरी पैक बनता है. तो आई थिंक जस्ट मूविंग ऑन टू व्हाट ऐश्वर्या वाज आस्किंग अर्लियर, फॉर अ probably a 5-year-old or a 10-year-old, how would you define a battery, how would you define a cell, how is it made, and what all goes on inside a battery?
More like 30-year-old, I think. Sorry?
5 or 10-year-old तो is very difficult
आई
to
नो वही मतलब हमने भी 8th 9th में ही पढ़ा हुआ है आई थिंक पहली बार से तो 12 13
16
साल
17 वो उसी
appropriate.
का रिफ्रेशर एक बार कर देते हैं.
So it's an electrochemical product. So basically, chemical energy gets converted into electrical energy. So, for example, a different technology would be mechanical to electrical, which is your renewables,
Hmm.
windmill, solar. Solar is also not that. Solar is actually a thermal to again electrical,
Hmm.
or solar energy to electrical, UV energy to electrical. This is battery is chemical to electrical and back to chemical when you charge it. How it happens is there are simply two electrodes, cathode and an anode. Whenever you're charging it, ions. So think of it as simple. If I don't get into the reactions internally, there are two reactions. There are reactions which happens. When you're charging, electrons go inside, they react, and ions move inside. So one, for example, ions don't move, electrons don't move inside the cell. There's a cathode, there's an anode, and then there's an electrolyte. There is no electron movement here. There is an ion movement. So lithium ion moves from one electrode to the other.
Hmm.
And when you're discharging it, the ion moves back. That's how you are. And lithium being a +1 valence electron, so +1 is what it oxidizes to and then reduces to when this reaction is happening. So it's a reaction that happens when you're charging, the electron goes in, there's a redox reaction which happens, and then that redox causes this ion to move. A potential difference to be created between the two electrodes. So whenever for example, whenever you're charging, there's a battery which gets connected to your battery, or for example, there is electrons which are moving from a solar source to there. Then what does that do? That creates an electrical force. If you remember, there's an electric field that gets created because of a potential difference that is generated. Potential difference and there's electrical field that gets generated. The ions which are converted through the reaction starts moving across that electric field. And that moves through the electrolyte as a salt bridge from one point to the other point. Now, more importantly, I think what people should know is, why do batteries degrade? Batteries degrade because when ions are moving from one electrode to the other, not thermodynamically, you don't get 100% of them back. Some of them stay there.
हाँ, कुछ तो लॉस इफेक्टिवली हो ही
That loss is those ions which are not coming back. So that is how these losses keep on happening, and that's your battery degradation that keeps on happening.
Got it.
So it's the most, I think, easy way of
And is there something called as a separator, which is like which prevents the flow of ions through the electrolyte, but instead goes through the device that you
No. So the separators work is to make sure that the cathode and the anode don't
come together.
Don't come together because of some reason. So the separator separates them. The separator is still it's a membrane, so it still allows ions to flow through. So it doesn't restrict ions. Ions have to go from one electrode to the other, and then only your reaction completes. If ion doesn't move from one electrode to the other, it only restricts in between, then there is no current flow, there's no electron flow, because your electron flow is on the outer circuit of the cell. So think of it, your electron is only moving from one electrode to the other electrode outside the cell. So your ions, if they don't move from one electrode to the other electrode internally, that complete circuit will not complete.
Right. Got it.
तो
बोलो
सॉरी, हाँ, तो ये बेसिकली ये तो एक सेल का हो गया, एंड आई थिंक सेल से बैटरी तक कैसे पहुंचे, क्योंकि बिकॉज दैट प्रोबब्ली कनेक्शन, इफ यू कैन एक्सपैंड ऑन.
So battery banate time, there are two things that you look at. One is capacity. When in terms of capacity, we call it a term called AH, ampere hour. How much of energy do you want? And the other is voltage. Voltage is the minimum voltage that an application would need to work. So certain applications are 48 volts, some are high voltage, which are 330 volt, etc. So home, most applications are at 24 volt, for example. So batteries, how they work is cells. So if you remember your electrical of 11th 12th, you remember that bada danda chota danda, which was a cell, right? अब मैं अगर उसको जब सीरीज में लगाता था, तो एक बड़े डंडे के सामने एक छोटा वाला आ जाता था लाइन में,
राइट.
दैट वाज सीरीज में सेल्स की वोल्टेज बढ़ जाती थी. सो इफ वन सेल इज, लेट्स सपोज अ 3 volt 3.2 volt 20 ampere hour cell, you put two cells in series, it is a 6.4 volt 20 ampere hour only. You're not increasing capacity, you're only increasing voltage. You'll only increase one of the parameters. Let's suppose mera application was 24 volt. and
Hmm.
100 Ah,
Hmm.
100 ampere hour. To put it in a better term, which people understand in terms of units of electricity, 24 volt 100 ampere hour is the energy that I need, let's suppose, to run my, for example, motor for 3 hours, let's suppose.
So
So
yeah.
24 volt 100 ampere hour is 24 into 100, 2.4 kilowatt hour or 2400 watt hour. You
Hmm.
multiply those two. So volt ampere becomes watt. So
Hmm.
let's suppose I want a 24 volt 100 ampere hour sort of energy in an
Hmm.
application for it to run 3 hours.
Hmm.
What I'll do is I'll take my cell is, let's suppose, a 3.2 volt cell.
Hmm.
So I'll take seven of them approximately, 7 to 8 of them in series. That will
Hmm.
be 21, 24 volt.
Right.
But my ampere hour of one cell was 10 Ah. So
10
when
a.m.
I connect them in series, I've got 24 volt 10 Ah. Now I will connect them in parallel, similar strings. So these strings will be connected in parallel then.
Hmm.
This will be called a module, the 24 volt 10 ampere, and I'll have 10 of these modules in parallel to create 100 Ah.
Hmm. समझ गया.
So when you connect it, so a battery pack is basically connecting all of these cells together in this arrangement
Hmm.
through bus bars. There are bus bars that copper bus bars that people use, and then connecting them through wires. The positive and the negative terminal comes out as major wires. It goes in a computer device called a BMS, battery management system, which also has a lot of sensing and so for example it has NTCs, which are temperature sensors. You put at different parts inside the battery pack to measure temperature. This is important for a battery health and
Hmm.
control the currents. Second, you also put in voltage sensing wires at different cells, because see, cell is a chemical product. It's not an electrical dumb product, and chemistry can go wrong.
Correct.
If chemistry goes wrong or is unpredictable, you need to tap into the voltage of each cell to understand how it's functioning. So
Hmm.
each battery management system also has voltage sensing wires. It has temperature sensing wires. Then it collects all of that data into an IC chip, and then that translates into certain outputs, which are then given to my vehicle controller. Then, so that's how a battery pack functions altogether.
Understood.
ठीक है.
Okay.
And now let's take a step back. एक बार सेल के अंदर तुमने बताया कैथोड, एनोड और इलेक्ट्रोलाइट है. You've also touched upon कि कैथोड कितने डिफरेंट तरीके के हैं. There was NMC, there is LFP, there is LTO. Okay, उन सब पे एक बार बारी बारी चलते हैं. Like मतलब what are the differences? And electrolytes, maybe you mentioned aqueous electrolyte versus I think you mentioned another one.
Electrolytes.
Yeah. So I think we can if you can touch upon the materials that are being used and कैसे इसका evolution हुआ है. You mentioned कि NMC से अब LFP और LTO पे सारा focus है. तो yeah, will help to
Keeping it a
understand.
bit broad, if you look at it, cathode materials and anode materials, though different. Anode में graphite was the traditional material which was used, just graphite. LTO is an anode material. So LTO को आप anode पे coat कर दोगे, so that's lithium titanate as an anode. You can use it with any cathode. Then now the new thing which is coming and which would be the future is silicon. Complete anode is silicon.
Hmm.
On the cathode side, you have LFP, which is lithium iron phosphate, which is one active material. NMC was another, which was nickel, manganese, cobalt. The third that is coming up is LMFP, lithium manganese iron phosphate. So there are multiple chemistries, LMO, lithium manganese oxide. So there are multiple chemistries there. We're seeing the world more. NMC was always there. Reason being, NMC had high energy density. So 200 watt hour per kg, for example, per kg of your battery will have, and automotive is very weight sensitive.
Hmm.
So 200 watt hour per kg. But then NMC had cobalt, cost was higher, etc. Life was less. 1,000 cycles was the life approximately. So 1,000 times you could charge discharge it, 100%. Then lithium iron phosphate has a 3,000 life cycles, but an energy density of 140 to 140 watt hour per kg. So that's what a LFP, lithium iron phosphate is. LMFP can have a high, and LFP, so cycle life was better. Your charge rates were lesser. NMC could charge a bit faster. LFP was lesser charge. Now LFP also people are bringing to fast charging a bit, and people are aggressively working on making LFP fast charge, LFP high energy density, because the moment that you do that, your NMC becomes obsolete, which the target is to remove cobalt completely. Then LTO is an anode chemistry. When you combine LTO with any of these chemistries, it gives you much higher power density. And when I say power density, higher in terms of charge rates. So you can do 10-minute charge. Our two-wheelers charge within 12 minutes, 0 to 100%. We are the fastest chargeable two-wheeler fleet globally today. So 12
Nice.
minutes, 0 to 100 because of LTO anode. Our cathode is still NMC, less, but our anode is LTO. So that's how LTO improved. But LTO has a penalty of energy density. My energy density is further lower than 140. So that's the trade-off. So it's a very big trade-off game. It's a very, very big. If someone wants to do some sort of just analytical research on it, Argonne National Lab has an online simulator, which is a very solid simulator of various chemistries, and you can do your random simulations and understanding what, because it's a very big combination game. And it's always a trade-off. There are three major things for trade-off: your cycle life, your energy density, and your charge rate. So you're just playing in these three. So that's how this is. NMC is not safe because temperature resilience is lesser. There is a term called thermal runaway in batteries, which is beyond a particular temperature. If the cell reaches, the reaction inside the cell is uncontrollable. So it will explode. So that is called the thermal runaway temperature. So NMC has a lesser thermal runaway temperature than LFP and all. So it's safer. LFP is safer overall. So that's how electrolyte, aqueous and organic electrolytes, not much difference in terms of performance. It's just that aqueous electrolyte making was difficult. So organic solvents are easier to absorb things, etc., additives and all, or aqueous takes time. So you need to find the right additives for aqueous electrolytes. All it helps is in lesser cost for sure, or you're moving from organic to water. Organic might be NMP. NMP was one of the main solvents before, but people are moving towards aqueous. So it reduces your emissions in the air because organic solvents also evaporate. So in your flow completely in your facility, if it is evaporating, it goes in the air, and it's then harmful from a greenhouse GHG emission sort of perspective.
Got it.
And I think you touched upon the BOM emissions in cell manufacturing earlier. तो इसमें again पूरा bill of material like क्या रहता है, and उसमें कौन-कौन से parts पे like मतलब emissions is a concern, or like things that you have looked into and like innovated.
माइनिंग पे है, इलेक्ट्रिसिटी कंजम्पशन पे काफी है. सो इलेक्ट्रिसिटी कंजम्पशन इज समथिंग व्हिच हैज टू बी ऑप्टिमाइज्ड, majorly because this needs a clean room. It needs a very controlled temperature and a controlled environment to create a cell. So that penalty is there. Cell mining, lithium mining and then lithium processing भी बहुत emission enabled होता है. So that is outside our purview. So what we are majorly focusing on is cell assembly or cell manufacturing, which would be from the time where we get the processed material, we mix it into a coating, and then we start the coating process. So lithium and cell processes, you get a slurry, you get a active materials, you mix it, a slurry is formed, you coat it on an aluminum foil or a copper foil, and then that gets rolled into a cell, because we make cylindrical cell. Some people make prismatic or rectangular cells, which is simple plates like this. We do cylindrical because why we have taken cylindrical? Because it's easier to process. It's a roll-to-roll manufacturing. So the coating comes out, it goes into a winding, unwinding machine, and it rolls into a cell. Then you put it into a metallic jar. Then in a more controlled environment, you insert electrolyte. Electrolyte impregnation happens. Then you close it, connect the terminals, and that's your cell. It's a complicated process overall. So that's what I say. Automotive and fundamentally batteries overall. If someone gets into this business, every engineering that you would have ever thought of.
Yeah, exactly. And it's just fascinating to hear from it. I cannot imagine कि like on the shop floor कैसा लगेगा.
If you come to a facility, you'll find materials engineers, you'll find chemical engineers working on process, you'll find electronics engineers working on battery management system and ICs. You'll find electrical engineers doing wire harnesses, bus bars, electrical architecture design. You'll find mechanical engineers doing structural simulations of the battery pack going into a vehicle. I think it is the most cross-functional system or company altogether if someone works with batteries.
No, very, very, very fascinating. Yeah, we'll definitely visit whenever I'm in Bangalore next.
Yeah, sure.
And so I think with that, I want to segue into the manufacturing process itself. So like, and maybe we can restrict it to cell assembly into battery packs, do things that you do. So what does that factory layout sort of look like? What are the different departments? What kind of, like you mentioned a number of teams already. If you could sort of walk through the value chain, maybe a factory. How does it look like layout wise? Yeah, Jesse, you want to explain in terms of what is that manufacturing process like? What does the factory look like?
It's a linear line. The cell manufacturing is a linear line. The battery pack manufacturing is a distributed line.
Okay.
The cell manufacturing will be a very linear line wherein the material gets fed from one part, slurry gets made, coating, and then out in the laser welding and making cells. So it's a complete linear line. It's a clean room. You can imagine a controlled, a pharmacy sort of manufacturing to an extent. So it's a controlled clean room with positive atmosphere inside, so that all dust is outside, everything is outside. That's cell manufacturing. So it's a very linear line. If you go to China and if you see those lines, so if you enter a Chinese cell manufacturing line, it's a 300-meter long line. So imagine yourself to be in a hallway which is 300 meters straight. And on the right, there is a line. On the left, there is a line. It's all linear.
Yeah.
So ours would be still hardly, I think, 30 to 40 meters today. The longest I've seen is a 300-meter line in China. So 100 meters to 300 meters is what these lines are usually for. So that's how this is a linear line. Next, I think in battery pack manufacturing, it's usually distributed. So you get cells. You collect data on cells in terms of by cycling it, charging and discharging. So whatever cells are there, you charge and discharge to assess a lot of parameters inside the cell. So you leverage electrical properties to assess chemical properties of the cell somehow. Those parameters then go in an algorithm that we've built, which gives us an identification of, see, there are a lot of cells that goes in a battery pack. Now, let's suppose if you're making thousands of battery packs, you're looking at 10,000s or 30,000s of cells going inside. But not every cell is identical. You have to make sure that the most identical cells go in a battery pack. So you leverage electrical charging and discharging through a machine to identify which cells can go in together through algorithms that you will build by experience. So that is called grading. So you do grading, you make those cells together, then it goes into module manufacturing, which is electrical, bus bars, etc. Some of the parts that we have are semi-automated with robotics. A lot of them are manual. It's still a manual driven because there is flexibility. It's still a moving vehicle. It's a moving product altogether. So we envisage that maybe 2-3 years down the line, there'll be more robotics in this. Though globally it is robotics. So it's arm-based manufacturing.
All right. Okay. Yash, do you want to touch upon anything? Otherwise, I want to next go into I think battery manufacturing की हमने बात कर लिया है, battery usage की भी बात कर लिया है, disposing and recycling के around I want to touch upon. But yeah, I mean, if Yash, you do not have anything else.
I think बस just मेरे को तो ये लग रहा है कि there was a dearth of good core jobs and which I think these guys are solving for chemical engineers, mechanical engineers के लिए एकदम cool कैसे दिखाना है and how does it actually impact the environment. I think that is a really nice kind of, I'm getting a very good vibe out of it. So yeah, I mean just wanted to add this, but we can move.
That's a very
good. For me, one of the major driving forces, and I keep on posting it on LinkedIn also, that now's the time when actually you can follow the passion with which you entered engineering. People used to take up mechanical because they were fascinated by a vehicle or a tractor, even people. So people used to like those products, but rarely anyone actually got into that field because of that opportunity being a problem, or in my opinion, an arbitrage of possibilities. People didn't know. There's a lot of awareness problem in, so for example, when I go to Roorkee for a talk in chemical engineering, I think those guys were asking me ki, for them, aaj bhi chemical engineering is ONGC IOCL. अब ना उसके बहुत आगे it has evolved. मतलब the idea in which people don't realize. For example, even in your laptops, your thermal management system below your laptop, which is fluids moving to keep it cool, it's a chemical engineering thing. We started fluid mechanics. We started microfluidics. No one thought microfluidics is, you can apply to a laptop. Hires it pretty well. Dell hires very good microfluidic engineers. So there are a lot of good fields available in almost every engineering. But people don't know about it at all. तो वो आई थिंक एक आर्बिट्राज अपने कॉलेजेस में तो बहुत ज्यादा इन टर्म्स ऑफ करिकुलम एंड मैचिंग द राइट करियर्स एज वेल.
Hmm. And also, like, I don't think there were like nearly as much focus on manufacturing in general. Like you said, this government, like, with the
Yeah.
Make in India movement, like there is a full focus on dedicated industries, and it has helped create a lot of opportunities.
No, for sure. Yeah, that's that.
Uh, Fantastic. So yeah, next step is like I want to understand the recycling part of it. So we get the lithium in. You use it in the battery, in the cells and the batteries, and then what does that recycling process look like? If I understand it right, you've also invested in recycling startups in your personal capacity. So yeah, curious to know what's happening there.
So batteries. So if you look at it, automotive standards say that you can take a battery to 80. So if you ever see a battery degradation curve, it goes like this, and then beyond a point there's a knee. So it's like this. So it is never linear to 0%. It doesn't go to zero. So it will go and keep on reducing its increasing its slope overall and become almost 100% 90 degrees at almost 70% SOH. So 70% जैसी life health बचेगी बैटरी की. When I say 70%, 70% is the energy that you are taking out and giving it. उसके बाद वो almost steep खत्म हो जाती है बैटरी. So automotive standard से 80% तक आप उसको ले जाओ. 80% is automotive allowed. 80% के बाद, in my opinion, till 70%, there is a market for repurposing a battery in stationary applications, wherein the applications are lesser power, lesser rugged. So वहां पे आप और कॉस्ट भी कम पड़ जाता है क्योंकि बैटरी ने ईवी में लाइफ कर दिया तो उसकी कॉस्ट खत्म हो चुकी है और डेप्रिशिएटेड एज एन एसेट. यू repurpose it, put it for 10% remaining life for and then you recycle it. So recycling में there are majorly there was, so why I invested in this company, this was, it's an IT Roorkee only junior, 2018, Meta. So he was in 2021. So he got introduced with some mutual friend, etc. So he was working on, he wrote a paper when he was in college about a different type of process to make to recycle. बट उसके बाद वही मतलब प्लेसमेंट वो लग गया. ही वाज इन सीके बिल्ड एट दैट टाइम, उसमें था. सो ही केम टू मी, ही सेड यार मैं इसमें काम कर रहा हूँ. आई सेड कि यार ठीक है, यू प्रूव दिस, you prove कि तेरा मटेरियल बनता है. So he actually was, so I loved his passion. He used to make it in his kitchen on a stove. He used to do recycling of batteries, and battery recycling is not only EVs. To be honest, EVs की batteries तो आनी अब शुरू हो रही है recycling के लिए. There's a big chunk of mobile batteries etc. which are already available. That is a major chunk. There's already there are mandis where these are sold. So he used to take them. And what his process was 60% in capex cheaper and 40% in opex cheaper than conventional technologies, not using solvents. They were very fascinating. And what happened by the time he came, so if you check, so his research paper that he wrote with the prof in college was being cited by people in Germany and China. Just started happening. So meant that there is some, things in it. So whatever he gave me as materials as proof, I sent it to IISc, got it tested and all, and proved that there was good purity. It was 85% pure at that time. So it was decent enough for me to say that I'll put in money and you scale this up. So 2021, he started it. So there are in recycling, there are majorly two processes: hydrometallurgy and pyrometallurgy. Hydrometallurgy is that you simply put it in a lot of solvents and dissolve the materials and then do chemical extractions. Pyrometallurgy is you simply burn it. So these two are the major technologies which were globally being already used for lithium-ion battery recycling. He took out a new material which was a chemical process under controlled environment. So it was a reduction process which was being leveraged in other industries, and he brought it in lithium-ion recycling. So what happens is recycling में manufacturing capex scale up करना बहुत challenge होता है बार-बार. Because your capex now of the process cheaper, he can scale factories much faster. And why opex and capex are important is because recycling of any waste to energy or any waste to any utilizing, the major pillar which needs to be solved is supply. People always get restricted on supply. Demand is not a challenge because definitely there is demand everywhere. If your process costs are cheaper, you can buy costlier. So that's the major funda in any recycling business. Because you are competing with 10 others who are buying the same amount of recyclable material out in the market. So it becomes a bidding process. That's why I said mandi. Batteries to mandi mein bikti hai, it's sort of a bidding. Now, if your process costs are lower, to maintain a good EBITDA or a margin, you can actually buy costlier, is the whole point here. So that's why this was innovative for me. So that company is doing that. So they set up a plant currently in Bangalore. In India, there are a couple of good companies there. Lohum is a good company based out of Noida, I guess, which are doing battery recycling and repurposement both. There's Ace Energy. There's the multiple, two, three now. Metastable is another, which is our investee. So I invested in my personal capacity. Akshay also invested with me. And then after that, now Sequoia is an investor. Surge also did the follow on afterward. They did the second round. They set up a factory in Bangalore itself.
Fantastic. And what is the name of this recycling hero?
So there is Shubham and Saurabh. These guys run it. Both of them are IIT Roorkee.
Okay.
So yeah.
Fantastic.
इसमें just one thing, तो मतलब as Log9, do you guys get involved in the recycling part of your battery packs, or like how does that work?
No, so if you see traditionally batteries companies had to do and OEMs had to do something called an EPR, extended producer responsibility.
Okay.
So you are responsible for whatever goes out in terms of recycling. So, but no one really got into it themselves, even in the lead acid era. So you partner with recyclers. So you need to, so we partner with recyclers with whom we say, okay, so you are my authorized recycler to pick up my material and do it. So that's my extent, but definitely, and in India, EPR was strong in the lead acid domain because it was more polluting as a chemistry. Lithium now it is becoming stronger. Someone needs to take the producer needs to take responsibility of those materials and those things coming back in the waste management cycle.
Producer in this case is the OEM.
That's still a woe, but ideally it will be the battery player. So we have to sign. We are under EPR.
Understood. समझ गया.
And so, Kartik, do you want to touch upon like the product portfolio that currently Log9 has? So I saw a bunch of things on your website, which is of course, the Rapid X series of batteries, the battery packs, which I think you've branded under ZapUp. And then there were like some other products like aluminum fuel cells, nano caps, that I also noticed. So yeah, can you put all of that into perspective? Like my business ka, like what percentage of your energy goes into each one of them, and how is it relevant in the grand scheme of things?
Our complete revenue is from the battery pack business currently. Battery pack is our last financial year. We did a $10 million top line. That was primarily through battery pack as a business. Which last financial year, I think 85% was three-wheelers. This financial year, two-wheelers and four-wheelers will also be a good chunk. So it's battery pack assembly as a business, but this financial year we will also start our cell manufacturing line. But everything that gets built in that cell manufacturing will be consumed by our battery pack business itself. It'll be an internal consumption. Then after that, we also have our mobility business. So we have three-wheeler commercial cargo vehicles, which is our major segment. Then we have now two-wheeler delivery and also four-wheeler one-tonner trucks, the Tata Ace product. So we retrofit those with a partner and then put it out in the market, which are also fast. So all of these are fast chargeable, rapid chargeable, in fact. So that is but this year we're also taking out other chemistries because all of these were LTO. We're now bringing out iron-based chemistries also, which are cheaper and making them not rapid charge because it's not possible, but at least fast charge. So that's how now we are also hopping onto that mass market. So because we feel LTO was a 15%, 20% market share, which we ourselves created. We're the biggest LTO player in India and Southeast Asia overall, in fact. So now we're entering into LFP and also will be pushing that. Stationary battery is still a smaller market for us. Not much focus there as of now. We tried that. We did that. We have our batteries running in Ladakh with defense. We have certain microgrids running in Bangalore. When I say a microgrid, it's an off-grid house, a complete house which runs on solar and our batteries. That's it. There's no grid connection. Now we're looking at South Africa because South Africa is a new booming telecom market and telecom always looks for batteries for backup so that's where we're looking at South Africa now as a new market for us. Stationary is a new market overall, but we feel with the last policy that has come in with that viability gap funding. So government has announced 3,000 crores. They'll be funding for battery storage for renewable. 3,000 crores, which is up to 40% that they've said. So that means around 9,000 crore worth of material will have to be made and deployed in the next 5 years, 7 years that they've given. It's a big market for us. And these systems are not smaller systems. So imagine that battery to be a container. It's a 20-foot container battery system. So that's the next foray for us also to get into that market.
Interesting, yeah.
And what about the aluminum fuel cells
Yeah.
and
So
nanocap?
aluminum fuel cell was one product we started in 2018. In fact, before batteries, we started 2018 and it is still under a project under research. We'll say we are at TRL 5 to 6 technology readiness level. We built a small system, we are looking at that system not as an EV application, but as a stationary diesel genset application
Okay.
replacement. So we feel diesel genset replacement क्या होता है कि when you pick up a lithium ion battery, you're actually putting up a high capex product with dedicated energy that you have to use. Otherwise, the capex cost doesn't get justified. डीजल जनरेटर का फायदा क्या होता था? इट वॉज लेसर केपेक्स बट हायर ओपेक्स, क्योंकि डीजल महंगा है. बट देन जहां पे अनप्रेडिक्टेबिलिटी ऑफ बैकअप है, वहां पे डीजल जेनसेट काम कर जाता है. क्योंकि अगर मुझे महीने में 5 घंटे ही यूज करना है कभी, तो आई वुड रादर पुट अ डीजल जेनसेट देन अ बैटरी, क्योंकि बैटरी का फिक्स केपेक्स है अक्रॉस टाइम. सो एल्यूमिनियम फ्यूल सेल इज सिमिलर, लो केपेक्स, higher opex because it's aluminum as a plate, but still at par to diesel. So that's what we're looking at. We're looking at the first stationary deployment happening in the next some quarters. But yeah, that is one project which is, so we have a 20-member team which works on aluminum fuel cells separately. So hopefully in the next few quarters, we'll see that product also coming out.
Sounds good. And I think last nanocaps.
There's nothing. So they were supercapacitors. So we built supercapacitors. It's already out there. We have certified supercapacitors. Just that the market is very niche of supercap. So supercap we built, as I said, just for understanding how to make cells. But in that period, we actually built a supercap. So the chemistry is with us, the tech is with us. So we can manufacture it if we need it. But so supercap is a technology which is, let's suppose if I was telling you energy densities, right? So LFP being at 140, LTO being around 80 to 100 watt per kg, supercap is 10 to 15.
Oh,
so it's a very low energy solution, but it is very high power. So it can give you, let's suppose I was saying LTO is a 12-minute chargeable product, which means it's a 5C product. 5C means 5C charging. It can give you 5 times the power. Supercap can give you almost 30 times the power. So it's a burst of energy.
Right.
So,
and what are the typical applications for that?
Medical applications are there for generating electromagnetic waves. Then secondly, supercaps. So metros, it has been used. In metros, whenever you're braking, a lot of that energy gets wasted, and it's a very high burst of power when a metro brakes. That energy can be stored in a supercap. So applications where there are bursts of energy, people leverage. So for example, also a wind turbine, if you have to rotate the pitch of the wind turbine, that is where supercaps are used, because you need a burst of power. You don't need a long duration power. You need a 5 minute of power, for example. So those are the applications where your burst of powers are needed.
Got it. And I also noticed like you have a very wealthy patent portfolio. So
Yeah.
I think any interesting innovations that are like in the development that you can speak about.
So I think it's a very constant thing. Every month we keep on filing 2 to 3 patents. It's just that it was such a nascent. It was just there was a big void already. So whatever you do can actually turn out, and the technology talent capital that we've built, it's a machine now. So it in itself, anything that it does actually turns out to be. It's just that we were very cognizant enough, because the moment when we were building the company from start, the idea was it'll be a hardware product company. We used to look up to Bosch as a company. When you look at Bosch as a company, you identify it with innovation and patents. So we have a patent team which works on anything that comes out from individual teams which are patentable. And it's not only restricted to materials or products in terms of design systems, etc. We've also started filing patents on softwares. So on software applications. So for example, blockchains, we're getting into blockchain for electric mobility, leveraging the data of battery, putting it in a blockchain. So something of that, creating a battery ledger. So we're working on multiple aspects where patentability was there. So, but right from material science to process engineering to design of a system, so a lot there. Yeah.
Beautiful. I think that might be a good segue into the culture of innovation that you're building, and I'm interested to sort of know what goes into behind that. I'm sure there's a lot of intention coming in from you guys as co-founders, but I'm curious to know, like, in terms of building a culture, what do you think are the building pieces there. But before we sort of go in there, I just want to take a quick pause and ask if Yash has any question around the cell manufacturing process or the product portfolio that we just discussed.
Yeah, I think we can move to the culture part. Very interested over there.
Take a say. So yeah, Kartik, what does it take to make an innovative company
I
like
think it's
Log9?
I think good decisions were around the team for sure. The founding team needs to be very, very solid. Our founding team, which were the same people who were with us since 2017, 18, are still with us. So that founding team was very critical of how you chose them. Plus, at that time, see, we were pre-revenue till 2020, 21. So for 3, 4 years being very pre-revenue, working on grants, etc., there was a culture already of patience and research. Patience, I'll not say. We were very definitely, patience was not there for sure, but research was there. So it was definitely it was a different type of culture, I'll say. There were companies, so software was faster turnaround, so, and hence aggressive growth. We were in hardware and we were trying to bring in what software had. So
Hmm.
our culture, we always call that we're trying to create. So Sequoia used to call it 2019 that we build hardware like people create software. So our turnaround times on innovations are faster. We found a lot of hacks around things. For example, testing, analysis, etc. We had ISC as a, so in my opinion, companies in our domain need to have a college as a or a research institution as a pivot for a lot of things. When we shifted, our whole focus of shifting to Bangalore was to one, talent being more available because engineering colleges are good here, and ISC was there. Secondly, ISC because we could use their complete analytical labs, etc. So on a pay per use basis. So we didn't need a lot of capital to bring in SEM, TEM, XRD, and all those machines. We could simply pay $1,000, get a sample tested. So those hacks helped us. Second, I think a market first approach was always good for us. We built a lot of products in this whole time period because fundamentally materials can be used anywhere. So we built a lot of products, and a lot of them were primarily because we understood the market and we did it. We understood that this is needed, let's build this. So from rather than just going haywire into a research and then looking at what output will come out of it, that's an academia thing. So this is more industrial. So you need to identify it was a product first approach rather than a material first approach. So that's something that we did. So a lot of us are not even the core engineers of what we deliver. So we most of Log9 is product management overall, and we're hardware product management. So I myself, I've never, all my electrical, electronics, etc. is what 11, 12th. But it's just that definitely there's a lot of reading that has gone in, etc. After that, which apart from me, a lot of the complete company has done. So, for example, people like Yash knows of Siddhant, Sid. He's a geophysical. That too, I don't know how he did. So, and now he talks in the language of C rates, energy densities, volumetric density, gravimetric density. So he knows those things. So I think it's a more product management DNA rather than a core research DNA which has brought us this far. If we would have a core research DNA, we would have died for sure.
Makes sense.
And I would imagine that that talent is like fundamentally very curious. So like again, what is that sort of again? Are there like regular learning and development sessions of sorts, like, or what is their learning appetite? Like
So
you
we have
mentioned
the
the collaboration with
internal.
ISC.
So we have it internally a lot. So we do these. So we have a lot of concepts like TGIF we do. Then we have these sessions wherein someone internally does a presentation of what they have done or found out for the whole group. If we find, so there are conferences which keep on happening, so we keep on sending people to those conferences for external learning. Consultants we did certain very good advisors or consultants who bring a lot on board. So that is there. But primarily, I think a lot of that is internal. See, a lot of this development is through research papers. For us, for example, software your Stack Overflow, we have ResearchGate and we have all of that. So we that is our primary reading material, which helps us cut down the time on research. Because the complete global, I think India for sure, the academia was very academia oriented. They never commercialized a lot of things which could have commercialized. So taking those bits and pieces and to putting together in a product is what we do well.
Hmm.
I hear you. Yeah, I mean, I felt that too. Like, for example, like a lot of the BTech projects just sit on the shelves at the end of the day. They're not
Uh,
commercialized. Uh, and in terms of hiring, like, what are there any particular things that have worked better for you than others? Like, and like, maybe what's the hiring? How does the hiring process at Log9 fundamentally differ from another company, maybe in your industry or in general?
I think it's very similar, but it's just that we have we did since 2018-19 we did shift a lot of focus towards colleges like RV, where there's more. See, though I come from an IT, but I know how much core I knew. I didn't know anything. Core knowledge is it's very obsolete what we used to study. There was no application oriented engineering at all that was taught to us, and a lot of that. But colleges like RV, if you go to RV, the culture is very different. For example, in our college, the very trendy groups were editorial groups. In people used to join an automotive group like a Team Knox for marketing.
Correct.
In RV, if you go, they have groups like robotics, which are pretty good. They have if their Team Knox sort of group is FSA, for example, used to have the same here in RV, is funded by the college itself because it's a small spawn. They fund it, and primarily the team only focuses on making the vehicle. In our college, आधे टाइम तो लोग स्पॉन्सरशिप्स में लगे रह जाते थे.
Correct.
So I think that culture we found in a lot of colleges, wherein we became a very and plus RV had a 6 months internship. A lot of these colleges have a last semester being complete internship, which was a beautiful thing to do. I think so. January to June, July, they used to come. See, there's 6 months you learn a lot. Second, for us, it's a good learning of you as a person, and we used to give PPOs to almost everyone.
Hmm.
And it used to be a good input. People who were and so I think RV 6 month was a big plus for us, and we leveraged that very heavily. We have a lot of people from RV. We fund we're a sponsor in their Chimera, which is their sports electric car team. We leverage a lot of that pipeline. I think we've been a major hiring company there, and specifically for this domain since 2018. And I think it is because people knew what they were talking about in their core engineering. I remember we didn't used to in 2018, 18 or 19. I think we went for hiring. Me and Hemant. Hemant is looks after our complete cell vertical. Both of us. I'm a chemical. He's a chemistry materials guy. We were interviewing electrical engineers. We didn't know anything in electrical ourselves. So the first guy came in, and very good story. एक बंदा आता है, उससे हम पूछते कि यार ये MOSFET we used to. अब we were more product managers. We used to know कि हाँ MOSFETs होने हैं for switching gates etc. तो हमने कहा MOSFET का कैसा होता है MOSFET. तो he drew the diagram of MOSFET on the whiteboard in the room. अब हम दोनों को ही नहीं पता वो सही है कि गलत है. तो हमने कहा चलो ठीक है. सो ही वेंट. तो अगला बंदा आया, हमने उससे पूछा भाई ये क्या बना हुआ है. उसने बोला MOSFET. तो हमने कहा चलो दोनों ही ठीक है. तो दोनों को ही पता है ये लोग क्या बोल रहे हैं. तो वी हायर्ड बोथ ऑफ देम. So this is how we went about it, but we never regretted these decisions because those people actually knew a lot they were talking about. We have people who have done a diploma before joining a college and then came here. And trust me, they rose to senior managers with us in last 5 years in hardcore engineering. So I think talent for us is definitely come. The talent is now, I think 3 years back there was no talent available. Now talent utna ka utna hi hai. But companies have increased drastically in this sector. So there's a talent for sure in this sector, at least in the battery pack or the EV domain. Cell domain to talent hi abhi bahut difficult hai. So we are in fact looking at we have this RISE program in which we partner with institutes and look at getting people in somehow, nurturing that talent, sponsoring projects. We're project running with IT Bombay on power electronics. We have project running with IT Madras. We keep on doing that. So that there is nothing. I don't think there is a big ROI out of any of that. It's just that there is at least a talent pool which is getting created.
Yeah, makes sense.
I think it also creates incentives for the students out there, right? मतलब to even pursue their course seriously. नहीं तो मैं वही I think अपन सबने देखा है ना, मतलब कॉलेज में जाके people are not actually focusing on the core of the things, right?
अरे मेरा कोई अगर कोई मुझसे बोले an alternate startup if I have to do is that problem to solve. It's a major problem. And पता है हम लोगों को तो वो बहुत problem दिखती नहीं. We did a seminar or a conference wherein we called all the colleges के major professors working in even दूर से at an arm's length on this field, and he brought them in a room in a hotel. They were close to, I think at that time, 25 to 30 academicians in a room. And you are asking them ki why are two problems? Why is talent not getting nurtured in core? Second, why are researchers not coming out of colleges? Because what is happening is, see, colleges are government funded. And ideally, researchers, if you go to the US, every other hardware company had some or the other technology coming out of a college, be it MIT, Stanford, etc. In India, ऐसा कुछ होता ही नहीं इतना. There are students coming out of colleges starting something up. So I think the only one pillar which is stabilized at least now is the incubation system of colleges, at least to an extent. But उसके अलावा colleges में से academic research translating into industrial is minuscule. So वहां पे एक gap था which we were trying to identify. So we realized it is becoming worse day by day. You go to tier 2, tier 3 colleges, the number of seats of software is to mechanical is so skewed. 3 जने एक मैकेनिकल क्लास में, 5 जने इलेक्ट्रिकल क्लास में, ऐसा होता जा रहा है. Now think of it, this will create and has already started creating a big imbalance of talent demand supply. Software में is going through a slump and is almost at saturation. Hardware, which is on a rising sector, has limited talent pool, and to create a talent pool is not a year's task. It is a long journey. So
4 साल की डिग्री तो होती है तो
4 साल की डिग्री है, वो साइलो तो क्रिएट हो ही गया मेरा पूरा का पूरा, वो खाली हो ही गया, मेरा void आ गया है पूरा बीच में. It's a big problem to solve, and that's where I think it needs a upgrade sort of approach today of crash coursing it and creating a talent pool. Crash course people in these segments.
or like a parallel diploma of sorts or things like that.
Correct. Yeah, so diploma has to move beyond just ITI or those basic diplomas. People need to start looking at diploma seriously, like people do it in Europe. Europe diplomas are looked after. लोग यहाँ से भाग के जाते हैं डिप्लोमा करने में, और यहाँ का डिप्लोमा को is looked at as such a low grade education qualification. That thought process needs to start changing, and diplomas need to be more better. Crash courses need to be more recognized.
Right. This is
this would also be a good kind of segue into matlab, so there are a lot of these problems which we are talking about, right, matlab, which are very systemic in nature and which have a very large role of the government, so to say, right, in solving them to a certain extent. So yeah, I think just a bit of retrospection on how you have worked with the government so far, how has the experience been, and like what are some of the good things, what are some of the bad things which you have probably felt working with the government to that?
We were a lot involved in, because our sector itself was a sector driven by the government. To be honest, how much did we have any say or were involved into getting that done was minuscule. It happened by itself. I think policies बहुत बनती हैं, but to be honest, I've seen policies like the FAME subsidy has been a major pull. So subsidy based policy अगर आती है, to be honest, that is the best pull for the government to create an industry. So I think FAME was good that they did. We worked a lot with government for grants and all, and I think it is very department specific. So METI department, which is the Ministry of, I think, Electronics, etc., Information Electronics. So that's a good department of the government. So we've taken grants from them. So we created a product which runs on drone, which was funded by them. So it was a grant that we got for creating a charger, which was a mobile fast charger. So we created a charger with power electronics on board onto a vehicle, which could be transported anywhere as a roadside assistance. Now they funded that project because definitely it was not a prime business, but it was a good technology for everyone to have. UK was already doing it. There was a company called HopCharge. So we said, okay, we'll do it. We had the talent, but resources had to be aligned, and even putting the talent there was a misplaced resource if we don't get the right funding for it. So they funded us. Now we have close to 20 of our own, we call it IOD, Instant Charge on Demand. It's already on roads in various cities. So some departments are good wherein you can get grants. Some departments are pathetic. There's no point even going there. We burnt our hands in certain departments where we were trying to take, for example, debt at that time. And a startup taking a debt is a big thing. And not now, so we do take because we're more confident behind revenues. But this is 2019 when we were trying to take debt from a government technology department. The time period of which they took to even come and sit with us and discuss about things, we were already equity funded. So that slow process and not a defined process create that ambiguity is where the challenge comes in various schemes that the government has. In various schemes which are very well written, it's pretty easy. For example, fame subsidy was pretty easy for people to start. Benefit scheme directly used. But schemes like those deadlines for startups, etc., was difficult to tap into. So it's very department specific, person specific a lot. Being a part of policy, I think with the creation of Niti Aayog, that has happened pretty well now. How they turned that think tank into a complete system was a very good move by the government, and wherein we saw now at least people are heard, even if action or no action, but at least it gets drafted somewhere. So Niti Aayog creates reports, very good reports. The quality of report generation in India has improved drastically with Niti Aayog coming in. It was pathetic before that. There was no data reporting only.
Right.
We have good data reporting happening, and it is through a lot of industry interaction which these guys do. They are reachable. Niti Aayog is a very reachable body. So you can call them, you can call the joint secretary, talk to him about your problems, etc. He might write a letter for you. Letter might be of use or not is secondary. But at least even till that extent, getting something reached was something which was never happening before this government for sure. So I think that is all aligned, and government also, I think, is moving at least relatively faster now. So for example, container-based battery energy systems, which I'm talking about, I was not expecting any policy in this segment coming in the next 2 years. I was thinking that they're already so busy with the EV thing altogether that this will be another business, another complete line for them. But they came out with it this year itself, which creates a market in itself for the next 5-6 years. And see, when they do this, they create a market for the world. Why people say EV is because when government creates a subsidy scheme for something like an EV, it nurtures a lot of manufacturers in India, which start then exporting as well. India is a major auto exporter for a lot of places around India. Even goes till Latin America. India exports, you will go to LATAM, you go to Mexico, you will find Bajaj ke autos running there. So this, either we could have lost that complete race again, like we did in solar. But this time, I think it was well in time. It was well in time. The subsidy was well in time, which created manufacturers to get into this because it created a scale to cater to. Same will happen in battery energy storage. Battery energy storage in India, though, is now 9,000 crore. Globally, it is a much bigger market already, being catered by China. One of the biggest companies, Siemens subsidiary called Fluence, does $1 billion revenue just on creating those battery energy systems for grid level projects. Where do they get their battery systems manufactured? Vietnam. Because in India, no one was getting any sort of... why China became so big in battery was because China created internal mandated demand for batteries. China was because China had two things. EV subsidies came pretty early. Second, China grid level renewable was much before. And when they were doing renewable, they created battery energy system need, which was, to be honest, bigger than EV at a point. And because of which a lot of cell and battery manufacturers scaled up their battery lines. Because unlike EV, battery energy storage for grid is a very straightforward project to set up a plant. It is simply cells coming out, putting into a system and deploying on the grid, which just gives you energy. Doesn't even need to be smart a lot as well. So that's what I think China scaled up their material supply chain, complete value chain so much that mammoth of economies that it has hit is difficult to compete now. But still, I think with India now starting the best business, this best market will evolve in India, which will then cater to Europe and US as well. Because those are very prime markets for it.
Makes sense.
Very insightful. And I think I'm also interested to know more about another aspect of your business, which is using venture or equity funding to do these large capex projects that you're doing. I'm curious to know about your experience in terms of like fundraising in general. You mentioned grants at first, then equity funding, and now a mix of debt and equity, including the funding from Amara Raja. So yeah, how has that journey been? What was your thought process in terms of picking these options along the way?
Correct. So I think when we started, it was more, so Tides was our first incubator and investor, a small check, 10 to 15 lakhs they funded at that time. After that, it became more angels. It was angels till 2019 when Sequoia Surge took us in and Xfinity invested. After that, I think what was good and is good for the ecosystem is since 2020, and Log9 being one of the first in that sector to get a strategic investment in such a hardware deep tech. Before us, Ather was known for the hero investment. So with Amar Raja and Petronas invested in us, that created a new wave of deep tech companies starting getting funding from strategics, because and that also not only was from a perspective of more strategics opening up their wallets to put in money, it was also a global indicator for VCs to put in money in early stage startups in this segment, knowing that a strategic might give an exit someday. Otherwise, that was always a missing piece in India, unlike other geographies. US and Europe strategics are very aggressive. Their CVC arms, corporate VC arms, are very strong. India corporate VCs are very small, either non-existent or small. But it became strong since 2020 a bit. For example, few that I know of, Marico has one. Uh, then Amar Raja now invests a bit.
Yeah, I think FMCG में तो बहुत ज़्यादा space है खुल गई
But
है
FMCG, look at India, that's not much. So ITC is only, though I come from IT, the only one thing that they've done is I think Yoga Bar deal that they've done.
right. I also noticed Tata
HUL has.
Consumer. Yeah, Tata Consumer also picking up businesses. But
TCB
yeah,
is coming up now. Yeah, TCB has now started coming up, but still new. And still they're looking at more established brands. Betting on an early stage startup, CVC is still very skeptical. But I've seen HUL, for example, has done minimalist. So some bets have been taken. But CVCs need to grow more. If you go to US, Johnson, etc., these guys have very awesome CVCs. Well, you can go at any stage and get funded. It's like that. Middle East was becoming a very good strategic investment opportunity. So now what that does is it creates a pull for only financial investors to go to those geographies, seeing a strategic will give an exist. And India would have lost for sure in that. But I think since 2020 now, a lot of investments have happened from not only in large cap, mid cap companies have started doing equity investments to an extent. So I think that was a big move for everyone. And we were, I think, that is one thing we take a lot of pride on, because we were one of the early there. Convincing someone like an Amar Raja and Petronas from Malaysia to invest in was a task. But getting that done now, after that, a lot of companies or a lot of entrepreneurs become confident of that, okay, I can create a hardware deep tech company, which is more research and hardware oriented, not software, and still get equity investment opportunities. So that started happening now. And I think once strategic opens, it's a very good alignment with a company like ours, because there is more knowledge flow. The board conversations are very good in terms of they're more, I think there's more understanding with each other in terms of discussions and problems and challenges and solutions. There's more synergy between companies. So strategic investment, I think beyond a point, it is always good to go for. Debt for sure. So now we fund a lot with debt. Our capex is a lot with debt only. It's just that early debt was from NBFCs. Now we're looking at PSUs. PSUs have started opening up another. The only thing is, so example, now we're at a growth stage. So investing at a growth stage is different. We are also now looking at, and maybe someone like a Sidbi is also opening up their wallets for early stage debts, which is a good. If you look in the last 2 years, the venture debt market also increased drastically. Entrepreneurs are going behind more venture debt as well. So I think the market has evolved in the last 5 years. It's evolved drastically. What it was 2019-20 for a Log9 and a Log9 for 23 is very different.
Got it. And you mentioned, so you touched upon a couple of points that I want to sort of further delve into. One is that you mentioned कि strategic को लाना was helpful in terms of attracting equity investments. Like that, did that happen in conjunction?
No,
Like,
no, not that way. So strategic को लाना helps the ecosystem for more equity investments to come in from VCs. So what happens is VC
तुम्हारे case में strategic आना is better for other players to sort of
startups to raise from. That's why you see in the last 3-4 years, see हम लोग बार-बार ये Sequoia, Surge, Axel इन लोगों की बात करते हैं, but those guys have moved more into growth stage investors now. They were early stage 7 years back. Now they're growth stage investors. But if you see in the last 3-4 years, a lot of early stage investors, new ones have cropped up. And people who are hardware specific, you look at someone like a Speciale Invest, you look at Avana Capital. These guys are investors which are majorly looking at e-planes, at space tech, agri-tech. It was non-existent.
Right.
I think prosperity के साथ साथ थोड़ा risk taking appetite in general has also gone up for the
ट्रेंड बना ना, because there was a trend as well. So एक तो positive trend macros में aligned था globally. Secondly, Indian strategics and corporates also started opening up, either absorbing technologies or companies or investing in them,
Hmm.
which was a major move for these guys to bet on. See, Indian consumer market to already badi thi, but for any VC to take a 5-7 years bet into something which is a patient business like a hardware was a big bet to take, until and unless, because सबका यही होता था ना यार कि हार्डवेयर में 5-7 साल लगते हैं, is enough for a legacy company to quickly push in capital and do it. So
Hmm.
हमेशा एक ये डिबेट होती थी, will legacy companies do everything in house or will they also go inorganic?
Hmm.
Inorganic in legacy in India was limited.
Yes.
You didn't see the best of the best corporates taking any startup bets a lot.
Hmm.
बहुत बड़ा एक, there was a very they used to invest in funds, but वो funds के through पैसा आना, वो they used to be funds of funds. A lot of these corporates were investors in a lot of Reliance also, and Kalari is a good LP. So
Hmm.
ऐसे वाले investments are, but were they ever directly involved in acquisition was a question mark. But I
Hmm.
think Reliance also, a lot of, though how they do it is debatable, but they pushed in a lot of money to startups in India.
Yeah.
Indirectly initially, now directly as well. That creates a lot of confidence for angel investing ecosystem, for early stage VCs to say, okay, I'll take a bet, because 5 साल के बाद क्या पता, अगर if I'm investing in a tire company, in a small tire startup working on, let's suppose, friction adjustment for tires dynamically in a vehicle, तो मुझे पता है कि क्या पता 5 साल बाद Apollo Tires might take this up and I'll get
Hmm.
my exit.
Correct.
So,
Makes sense. And Indian family offices, abhi recently on this podcast, what the fuck is venture capital with
Yeah,
Nikhil?
yeah.
I learned that the Indian family offices are very, limited partners in a VC fund. Like they don't invest a lot, and most of this capital is coming from outside India. It could be different for players like Kalari, but I think there was Sequoia, Rajan was there,
Yeah, yeah.
Axel, and Bloom, and none of them, except for Bloom, none of
They
them
are
suggested
smaller if
Indian
you
family
call it
offices.
in terms of the proportion of what money they raise. But if you see in terms of the growth of that Indian market itself in the last 5 years,
hmm.
that
What do
has
you
grown.
mean?
Because 2019-20, I remember 2018-19, if I used to find or we used to go for any family, there was a dearth of people who used to look at this.
Hmm.
But now if you look at it, there are more family offices who have started reaching out on LinkedIn itself that it's a formal family house for investments.
Right. I hear you. Yeah.
So that has started happening. I've seen, you look at it now in terms of family offices, even celebrity investments have increased.
Yeah.
When did you used to see 2018-19? Did you ever hear a Bollywood celebrity of that era putting in money in a
Hmm.
startup? But now you look at it, I can identify 5 of them, just I know that who have put in money
Hmm.
in consumer brands, because it definitely aligns with their thesis. So sports celebrities or Bollywood celebrities putting in money, it's a big difference in this market.
For sure.
Makes
And
sense.
any learnings that you have had from you said that the investment from Amara Raja was relatively early in this space. What was your experience like in terms of reaching out to that family office, working with them? How was it different, let's say, with a typical VC fund? Uh, if you could touch upon that, maybe.
It very much depends on the family office or the company corporate you're talking to. Reference always helps. This was through a reference. So one of the our super angels, and because I worked in ITC, so my CEO was my reporting manager, who's also an investor in Log9 at early stage. So Sanjeev Rangras, he's a super angel in India. He's invested in almost every other ITC company startup when he was there. Now he's retired. Zetwork was his investment. Then Blackbuck was his investment. Off Business was his investment. Log9 is an investment. So he was, because I was based in Guntur and Jay Galla was MP in Guntur. So Jay Galla was known to Rangi very well. So he referred with that reference, and it was also coincidence, serendipity, that at that time Amar Raja was getting into new energy business altogether, and they were looking at, and they realized that inorganic would be a good way of going about the technology part of it. Scalability they can look at. So
Hmm.
that's where I think there was an alignment, and it was good. I think people matter a lot in that journey. So good people we talked to. Vijay, Vikram, these guys are pretty good who lead that complete vision of Amar Raja to move from lead acid to also lithium. So, or other energy storage technology. So that was, I think, a good alignment. So people matter a lot in this. And those discussions are much different than what you have with the VC. It's more around future alignment of how the markets will align. When I say markets will align in terms of technology, so they understand technology much better than VCs for sure. They have much better insights. They have seen, for example, someone like an Amar Raja has seen the same trajectory of a lead acid becoming a major tech. We have seen how it requires pitching in from all of the ecosystem players, government, consumers, corporates, etc. So that insight is something which is very fruitful. Those discussions are much better. VCs are more around 5-7 years. How will this macro shape up, and how are you different? Then how are you different is very subjective to how much the person sitting in front of you understands what he's talking about. So at times I might invest in companies which are not even different, but I see a dearth of companies in that sector. So that understanding comes better from a market veteran. So for example, in ITC, when I was there, the mantra was never to be a first in any category. It was always to be a second, because it was simple. The first has a lot of burn in education. The market is big enough for a second and a third and a fourth. So don't be a fourth or a fifth so that you're too late. Don't be a first so that you burn a lot of capital in that early stage to create a market. So you
Yeah,
that see a
and
lot of
especially true for and especially true for market जहाँ पे मतलब like there is not going to be a single person leading,
correct.
especially the internet place. Yeah, makes sense. I think we can wrap
Yeah.
up with the last question around. I'm sorry if you're keeping you, but yeah, we'll just wrap up this with the last one question. In terms of like, if you reflect back on your journey, like let's say when you graduated out of college or you were working at ITC, how has the Log9 journey been a force to shape your career, shape you as an individual, shape you as a conscious capitalist?
Okay. I think it's more around. So when I was in college, I definitely, even in my first year, second year, I wanted to do something which was more impactful. When I say impactful, my scale of impact is, okay, there's social environment and all that. My idea was to touch as many consumers as I can myself, or bringing about. So I used to always look at these challenges, and this is something I learned in college, because I think my second year working in Cogni, the tech fest, and that too in the market, that was when I learned that there's a concept of a startup which can actually challenge a problem and create it into an opportunity, convert it into an opportunity. And I think that's what has happened in my so I always, for me, creating something which is of scale drives me most. And that's something that I learned across my journey from college itself. ITC was a very small 8-month stint in which I actually learned how people drive what gets driven ultimately. ITC is a people's company, and that people is not only internal employees, but it's also external farmers. Right from the farmers, how do you drive a business? So I understood the importance of stakeholders in a value chain. So driving everything together, and I saw that it's much more than money. To be honest, it's much more than money. For ITC, whenever I tell someone about ITC is, I rarely tell them that it's a multi-billion-dollar conglomerate. I tell them it supports 2 million farmers in India. So that's how you drive impact. You support 2 million farmers in India. You cater to the maximum produce in India and create an exportable product out of it. Now that's what is an impact is. Being a multi-million profit, billion profit company, it's a byproduct. Where if you're able to convert an natural resource in your country as an exportable product, profits will follow. But the whole vision of thinking that, okay, can I create I'm already dealing in tobacco and I'm already dealing in these farm produce, can I create a product for consumers, is vision. Similarly, in Log9, we were sitting in a small office when we used to see drivers below, because we were in that Ramaiya ka hostel area. So we used to see Zomato, Swiggy drivers, and we realized, these guys need EVs. And the EVs that they need needs to be fast chargeable, because it's a hub and spoke application. The scale of it was so humongous. We were saying, okay, we'll burn whatever is needed to be burned. We also had our hiccups. We had times when we had no funding for months, didn't have salaries, didn't have money to pay rents. We saw all of that. But then it was worthwhile, because we envisaged there will be a day where there'll be thousands of people using our product, which would be meaningful, changing someone's life. So I think the scale of impact, no matter in what way, is something that has become a driving force. And I think with this changed ecosystem and industry and country, more confidence in thinking that even in whatever background you come from, in terms of what sort of household you come from, but any problem in this society can be an opportunity for you to solve, is possible today, was not possible 10 years back. And I think that is some confidence that I feel is should be more inculcated with more people, that guys, it's fine, problems are, it's good to have problems, because then you have something to do, something to get up for. So I think, yeah.
Right.
Right. So let's take that message to more people with this podcast. Thanks
Yeah.
for your time, Kartik.
Thanks so much.
Thank you, guys.
I think Kartik, एक और बार अलग से I'll also probably set up another call more on the personal front. I know that there are a lot of things that you do. I think I was telling Aishwarya also कि कई जगह businesses set up करके then you have handed over to people. So yeah, that would be an interesting kind of personal growth model, so to say, for people to kind of know about. So yes, let's catch up on that as well.
Done. Sounds good.
चलो.
Thanks a lot, guys. Thank you.
I hope you enjoyed the conversation as well.
Yeah, I loved it.
चलो भाई.
All right then. Take care. We'll be in touch. Take care.
Yes.
Bye.
So that was it, folks. ये था हमारा third episode with Log9 and Kartik talking about energy. And this was a very illuminating episode personally for me. And it was very refreshing to see Kartik's perspective and the love that he holds for his own work. एक चीज़ जो मुझे सीखने को मिली वो ये रही probably कि the power to change lies within us. And I think there are always troughs in your own journey, but at the end of it you have to do something which makes it worthwhile. And I think वो काफ़ी अच्छा टेक अवे है मेरे लिए personally. And I think काफ़ी लोगों के अंदर वो insight हुआ होगा. And आपको अगर ये पसंद आया हो एपिसोड तो प्लीज़ डू लाइक, शेयर एंड सब्सक्राइब. And please do share it with people you think it might be relevant for, या जिसको पसंद हो इस तरीके के conversations. Till the next time, this is Yash signing off.